Hi, everyone. Good afternoon. Welcome to the session. Uh, I can see a lot of you have already joined in, and some of you, I can still see some people trickling in. So I'll give everyone a minute anyway. We have a power pack 2 days in front of us. Most of you know we are doing this today and tomorrow over a span of 4 sessions, 2 sessions today, 2 sessions tomorrow. So if you were at a point where you wanted to make sense of all the AI talks that's going around you, all those videos on AI that you're seeing on YouTube or your social media feed, or your friends are sending you something. If you want to make sense of it, this is the right place where you can start. So the sessions are also divided like that. But before I start, I want to know you better, right? So I'm going to launch one poll, which I'm going to, keep it launched. So once you answer it, it'll go off from your screen, and then I'll start with the session. This poll will primarily help me understand what are you looking for in terms of what are your career aspirations this year. And if you, beyond this session, you want to talk to us for a structured uh, pathway to get AI enabled, then let us know. We'll reach out to you accordingly. But having said that, I'm going to just share my screen now. And I'm also going to share a few things in the chat. I'll keep sharing a few things in the chat. The chat as well as the Q&A section, it's open for you. Uh, I'll tell the speaker once I introduce the speaker will help you basically. We'll go through the things that you note over there and we'll answer the questions. So I'm going to share my screen. Just let me know, like a thumbs up or something, that you can see it. Or Surit, you can also just say if it's
I can see your screen.
awesome. Thanks. So again, welcome everybody. I think most of you have joined in. I can still see many people coming in, but this is the right time to start. So we are on day one, session one. So like I said, this will go on for 2 days, today and tomorrow, 4 sessions for you. And what are we going to cover? In the first session right now, we are going to cover foundations of AI, specifically agentic AI, and we'll set the foundational learning for all of us, right? The baseline, so that then we can move on to our next session, which is with another speaker, and we are going to build our first AI agent. If you haven't done already, if you have, great, you'll be super fast in doing that. If you haven't, then great place to start even today. Tomorrow is super interesting again. We are going to first session talk about multi-agents and orchestration, and then we'll go into deep from demo to production, basically get something production ready in on a multi-agent level, right? So either by now or I'll also post the Discord community and the Slack community link in the chat as soon as I stop sharing. You'll get these free resources. Okay, the day one resource that you would have gotten or will get once you join the communities that I'll share is the AI use case discovery guide. Okay, so it's a step-by-step toolkit. Go through it. Very helpful, great for starters, and great for beginners. On day two, we will have another playbook. Tomorrow, I can share the same thing with you. So, who is the session for, firstly, right? And I would say everybody, every tech professional out there, the session is for you. If you are a IC engineer, if you look after a team of engineers, if you're a TPM, if you're a product manager, you're a data engineer, you are an engineering manager, you're a leader already, this is the place to start. Because by the end of 2 days, you're going to start if you haven't already, an AI pilot in your own domain. Okay, you're going to try something out. You're going to be encouraged to try something out. Okay, that's what we have seen in our past sessions. I'm going to vouch for it. You're going to get super curious after these sessions. So a little about Interview Kickstart. Some of you know us already because in the audience we also have a lot of alums who keep attending these sessions. But for some of you, we are new, right? But we are not new in the industry. We have been doing this for the last 12 years. We started in the Silicon Valley, and 10 plus years, almost 12 now. And we started in the Silicon Valley as an interview preparation company, and we soon, in the last 5 years, pivoted to also AI enablement and AI upskilling, right? We particularly cater to 18 different tech domains. We do not treat you as a single tech professionals and take the same route. No, we customize the offering that we do to you in AI upleveling as well as interview preparation. Our secret sauce is our FAANG instructors. We have 700 plus of them. And these are the folks who are actually scaling AI systems in real life at their jobs in companies like Meta, Amazon, Google, and the works. And they are going, and as after their day job, they teach you all of what they are doing live, right? So that's the best kind of learning specifically for a subject like AI. We already almost 30,000 people have done that, 27,000 to be exact. And we have seen great success, not just in terms of compensation, but in terms of transition, our learners moving into kind of roles that they always wanted to. There are some numbers in front of you that you can already see. Now, this is the secret sauce I spoke to you about, and you'll see a sort of a window into this through these sessions, because all of the people all of the 3 to 4 people who are going to take sessions the next 2 days, today and tomorrow, they are our instructors, right? Surhit being one of them, who is our speaker for session one. Firstly, Surhit, thanks for joining. I know it's super, super early for you. By the way, guys, it's 2:30 a.m. for you right now. Yeah.
It's
So
2:30
he's
a.m.
joining
to
us from
Portugal.
the US. And thanks for joining, Surit. That's super sweet. And I think that talks about the passion of teaching that you have. Not just passion for teaching, he has superb amount of experience, 15 plus years of experience just in AI ML, and worked with all of the names that you can see in front of you. He's a PhD from MIT, and he's currently in a climate change company and leading the ML over there. So I've done many sessions with Surit, so I know what he's doing currently. So Surit, thanks for joining in. I'm going to hand it over to you, but again, just a reminder: if you have questions, you can leave it in the chat. Surit will go through it. So this session is till about 1:30, 1:40 p.m. IST. So another 1.5 hours that we can hear Surit. He'll try to answer some questions. If some are left, we'll answer them towards the end of the second session, right? So uh, don't worry if some of the questions are missed in the first session. But go ahead anyway, post. He'll keep interacting with you. So Surya, I'm handing it over to you. You
Sure.
can go ahead, share your screen. And I'm hoping everybody has answered the poll. Thank you.
Can folks see my screen? Can someone confirm?
Yes, yes.
Perfect. Uh, Great. So, thanks, Nidhi, for the introduction. Without further ado, I'll just begin with the agenda, but a brief introduction about myself, as Nidhi already mentioned. I'm Surya Deshmukh. I'm a director of machine learning at a climate tech company. Before this, I was at TikTok, leading their e-commerce recommendation and machine learning science. And I've worked in a variety of startups and e-commerce companies, leading a data-driven initiatives to solve complex business problems. So today specifically, we'll begin with why AI, why now. We'll go through the transition that the industry has seen from pure data-driven modeling to classical ML to deep learning methods to this generative AI and LLMs. We all know how the early versions of ChatGPT or any LLM for that matter hallucinated, right? Where you would like ask it something which is factually true, but it would come back with an answer which is not true. We'll talk about retrieval augmented generation, which essentially helps you reduce these hallucinations. And then for designing retrieval augmented generation systems, or RAG as we call them, there are a few different pieces that we need to think about. So a few of those are chunking and embeddings and vector databases and prompt engineering and so on. And finally, we'll move on to agents and architectures, and then some agent development frameworks. So that's the agenda for today. So I think Niyati already alluded to this, so I won't really I won't mention this thing in too much detail, but generative AI has moved from like just a an academic piece of literature to actually something that is being used in the industry and beyond on a day-to-day basis, right? So AI adoption has skyrocketed. Most of the tech companies and non-tech companies also, to be honest, have adopted some flavor of AI-enabled work within their workforce. And generative AI has gained millions of users faster than any tech in history. And so it has seen historic pace, it has seen a record growth, it has seen a rapid adoption. And so there's no better time to learn the inner workings of generative AI and its capabilities than today. So some of the success patterns from the industry include Uber Genie, which is like their internal AI-powered support engine, GitHub Copilot, which is Microsoft's development. GitHub Copilots, if there's any software engineers or data engineers in the audience, maybe some of you folks are available with it. It helps you. It's their coding enabled agent. Intuit assists. So all of these. Intuit is like a tax processing company that has a variety of financial products, and it also has its own LLM powered engine that helps bookkeeping and accounting and financial related tasks for more than 10 million small business and small companies. So as you can see, this is not just an academic exercise anymore. Gen AI powered applications are powering day-to-day initiatives from companies big and small, tech versus non-tech, and everything in between. And I don't want to project a doomsday scenario. I think tech has always changed. If you really look at the history of tech, right, from World War II to like every decade, there always has been changes in manufacturing, there have been changes in medical science and defense, in software and computing and so on. And today it's no different. So I don't want to portray a doomsday scenario here. But what I will say is a lot of jobs are getting displaced, not necessarily because there is no work, but they are getting displaced because the nature of work itself is changing. So as a result of that, there are these new roles that are coming in, like AI engineers and data and ML specialists and AI ethics consultants, because a lot of these LLMs and Gen AI based solutions have ethical concerns. What if you are training them on substandard data? What if you're training them on biased data? Then it's going to produce biased results. And so there's a lot of new trust and safety, ethics, AI-enabled safety roles that are popping up. And that's where most of us need to be. Most of us need to slightly reskill ourselves, reorient ourselves with the domain expertise that we already have, but just make that domain, see how we can apply AI in that domain. And so that's where we help. So the innovation gap is something that we can help address. Organizations which are slow to adopt AI will be at a risk of not staying up to date with their competitors. And on the other hand, those who actually use AI in an intelligent manner will actually see their productivity grow quite a bit, right? So, what is Gen AI? Gen AI refers to the use of AI to create new content as opposed to something like predictive AI or predictive analytics, where essentially you just use your previous data and your previous training data and sample something from your previous training data to make a prediction. Generative AI essentially generates content which is quote unquote out of distribution. What I mean by that is, if you ask your new image generation diffusion model to create an image of Taj Mahal, but in a Van Gogh style painting, right? It will be able to do that. Why? Because that is its core capability to generate new things. It doesn't need to have an image of Taj Mahal with Van Gogh style painting in its training data, and that's why the name generative AI. It creates new content. And all of these generative AI techniques, especially the text-based ones, are powered by foundation models, as they are called. These are like large AI models that can do multitask learning and also perform these out of distribution tasks, right? And some of the use cases of Gen AI are content creation. So a lot of marketing agencies, ad agencies use Gen AI techniques for content creation, visual design, creating the example I gave, creating images, code generations with code generation. Some of us might be familiar with that. Customer support, data analysis, personalization. These are all some of the use cases which are very heavily used, which can heavily leverage Gen AI. So before we talk about Gen AI, a critical piece within this Gen AI revolution is the large language model. So what are LLMs? Why are they called large language models? They are large because the amount of that because of two reasons actually. They are large because they are these giant neural network architectures which have billions of parameters, right? So GPT-5, for example, has more than 175 billion or something parameters. They are trained on large amounts of data, and so that's why they are large. They typically deal with a language. So these days you have uh, most of the LLMs that we are familiar with are English-based LLMs, but you have LLMs coming up in other types of languages also. So that's why language and model because it's a mathematical model. So that's why the name large language model, and they are built on this transformer based architecture. This is just a complex neural network based architecture that was published by Google researchers in 2017. So within a decade, within less than 10 years, this has gone from a research based solution to a very practical feasible solution that is being used every day. And some of the capabilities of LLMs are context recommendation, information extraction. So, given a report, extract some useful pieces from it. Sentiment analysis. Um, Sentiment analysis is something like if a product review is positive or negative. Text categorization, given a piece of text, does it belong to physics, sports, science, biology, and so on. Question answering about a particular topic, um, language translation, going from, let's say, German to English, text summarization, and general natural language processing associated with tasks like these. So clearly, they are very, very capable and powerful. But that being said, they still have some limitations. They have dependence on their training data at the end of the day. They can generate out of distribution examples, but can generate uh, they still have a certain amount of dependence on their training data for knowledge. They lack true understanding. They are at the end of the day next word predictors or next token predictors, as we call them. If I feed it a lot of wrong examples, it's going to come out with wrong examples also. And that's exactly why they are vulnerable to misinformation. You need a lot of compute to actually run these systems, a lot of infrastructure, a lot of memory requirements to do something useful with LLMs, and they have knowledge cutoff. So, for example, if an LLM was trained up until 2022, you cannot ask it who won the Cricket World Cup in T20 in 2026, right? Because it doesn't have that knowledge. So the knowledge cutoff is another aspect of it. So here's a challenge. How will our agent know company specific information? For example, so there's two aspects here. Let's say there's a company specific information that was generated in 2026, and let's say our LLM has a knowledge cutoff from 2025. So clearly that's one thing why it wouldn't be able to answer this. The second thing is, what if it was not trained on our company specific information in the first place? Because this is proprietary information. So how can we solve this issue? Anybody in the chat? Exactly. So I think people are pointing towards the right solution. So one thing that we can use is something that is known as a retrieval augmented generation or RAG. It's like giving these large language models a search engine. So before these LLMs can answer a question for you, they typically go and search for the answer elsewhere, which is not in their training data. and see if something that the user is asking for matches very well. So, for example, typically a RAG-based pipeline would look like a user query comes in. This is a user asking who won the Cricket World Cup in 2026 for T20. Maybe my LLM was GPT-3, which has a cutoff date much before 2026. But let's say I maintain a database where I store all the documents associated with sports news up until today. So what will happen is, instead of this user query getting directly asked to this LLM, what happens is this user query goes into the vector DB first and searches, okay, this person is asking about Cricket World Cup 2026, who won the thing. And so hopefully we have the documents associated with the fact that India won the World Cup. And so we retrieve that document as the very first um, piece of information. And some other relevant pieces like what the final score was, the final match was between India and New Zealand, and so on, right? And you get all of those relevant information, pass that to the LLM, and now even if your LLM was trained up until 2022, let's say, it has all the knowledge that it needs within its prompt to just summarize the information for you. And that's what it will use for generating that response. And this is what is being shown here in a little bit more detail. So this query, which is the user query, is converted into a mathematical representation called an embedding. That embedding lets you compare and find the most relevant embedding from your documents are also converted to this mathematical representation. You do some cosine similarity, which is a mathematical technique to find how close together two pieces of sentences are semantically. And we'll learn about what that exactly means a little bit later. But long story short, for now, just remember it just tries to identify what are the pieces of information within all of these documents which are closest to the user query. It searches that from the vector database and gathers all of those relevant chunks and passes those to the LLM and gets the response, right? So these are the different pieces that are required to generate a RAG-based solution. So as a result of this, what are some of the benefits of RAG? Because we are providing it with certain documents, you can get up-to-date answers. Your answers will be accurate and grounded in some factual information, so that reduces hallucination. You can use smaller LLMs. You don't need latest and greatest LLMs with all the latest information that they have been trained on. A small LLM with powerful resources and tools can outperform a larger LLM with no access to no tools and no access to up-to-date information. You can use it for domain adaptation. So let's say you use a generic LLM, but now you want this LLM to become a knowledgeable LLM in financial information and financial news. You can do that without any training, right? You can just change the data that is stored in this vector database. This thing can contain finance data now instead of sports news, and now you got a finance expert LLM. And traceability. So there's a lot of tools out there that enable observation and evaluation of LLMs, and that goes into the traceability aspect of them also. And one important thing when it comes to designing a RAG-based system is chunking. AI systems don't read like us. They need help understanding long context. And so that's where this chunking comes in. And what that really means is that if you pass thousands and thousands of words to a small, like these days, LLMs are getting very powerful, so they can actually process long text fairly well, but still there's a limit. If you pass a long text to some of the earlier models, they won't be able to process that long context very well, even if it is within their context window. There's something known as a recency bias. What that means is that it takes the first few paragraphs and the last few paragraphs and forgets the information in between. And so what really helps to make those answers precise is not sending the entire document about, let's go with the World Cup example, not sending the entire list of all the matches in the World Cup and all the scores and all the tables. We said who won the World Cup. So maybe we want the information only about the final match, right? And so identifying that particular chunk or piece of document that only talks about that India-New Zealand match. So chunking essentially means breaking down a piece of document into small parts such that they can be loaded into the vector database and retrieved in these smaller chunks as opposed to retrieving all of it at once. So chunking essentially means breaking up a piece of text into smaller pieces. It makes it, as a result of chunking, it makes it efficient for AI models to process and understand large documents efficiently, and helps maintain context by feeding the right chunks to the model at the right time, right? For example, we talked about this, who won the final, and so we can feed only those chunks associated with that final match and the scores and so on and so forth. And essentially, there are various different chunking strategies. Um, there's sentence-based chunking, there's word-based chunking, there's paragraph-based chunking, and we'll talk a little bit about that. But essentially, one example of a chunking strategy, there's a fixed length chunking strategy. So you take fixed amount of characters and break it at some point. You take another fixed amount of characters, break it at some point. So there's multiple different strategies associated with chunking. But long story short, chunking means breaking a piece of document into smaller pieces for more efficient consumption by large language model. So um, typically, what happens when you have a document is that you select one particular strategy for chunking, and how to select a strategy is there's it's an iterative process on exactly how you can chunk. But let's say you have a strategy to chunk. Let's say you use paragraph-based chunking. So one paragraph is one chunk. You break all the paragraphs down in the document, convert them into this mathematical representation, and store them in this vector database. Um, so from now on, whenever a LLM, especially in a RAG-based system, is going to retrieve information, it's going to retrieve these chunks. So that's going to be our unit of work. So that was chunking. The next thing that I want to talk about is embedding. So embedding refers to the fact of converting these pieces of text, smaller pieces of text, into a mathematical representation that captures semantic meaning. So what does semantic meaning mean? Think about it this way. Let's say I'm working with an insurance company and I want to retrieve all the documents associated with car insurance. Um, if I use keyword mapping, so keyword mapping would mean the documents should have the word car and insurance within them. And so, okay, that will work in for a limited case. But automobile insurance, vehicle insurance, car insurance, scooter insurance is somewhat similar to the kinds of insurance associated with a transport vehicle that I'm looking for, right? But if you do a string matching for vehicle and car, you're not going to get a good match in terms of string matching. And that's where semantic meaning comes in. So semantic meaning means capturing what that word actually means and trying to retrieve based on that. And that's what embedding enable us to do. So what is an embedding? Embedding essentially is a mathematical representation for a piece of text. And so what that really means is words. Imagine words like cat, kitten, puppy, dog living close to each other, and something like helicopter or mountain or ocean living completely in a different direction than stuff like this. And so you can group similar things that mean the same thing together. So how are these embeddings generated? Embeddings themselves are generated in by using lots of training data, and you have neural network models, deep learning models to create these vector embeddings for large pieces of text and image and audio and a variety of other modalities and unstructured data. And at the end of the day, what you're doing is you are converting this input into a mathematical representation, which is a series of numbers like this. So that's your vector embeddings. So again, what that really means is that you take your content, you take an embedding model, and this can be a neural network, some other model like word2vec, glove, transformer based architecture like BERT, if folks are familiar, convert them into some mathematical representation like this. And then when it lives in the database, what you can do is cluster the chunks. Each of these yellow dots are chunks such that similar chunks live close together. That's the whole point of creating an embedding and storing it in a vector database. So, so um, right. So, why do these embeddings matter? As I said previously, we can answer questions like who won the World Cup at time t, and it can find relevant passages by these vector similarity for questions. Um, we can find text that means the same thing and not just keyword matching, my insurance example. And it can also we can also do personalization. So if you talk about a trip to Paris, then maybe we can also retrieve documents um, which are very relevant to something about Paris and trip organization, itinerary, and so on. And vector DBs enable you to apply efficient retrieval algorithms to this semantic meaning as well. So, right. So why do embeddings matter? Embeddings matter because they enable semantic search, the correct context retrieval, uh, personalization, meaning you can capture embeddings for some specific recommendations that you're asking for, and applying efficient mathematical techniques to one, encode the piece of text as a mathematical representation, and two, to actually retrieve them fast from this unstructured vector database. So, and again, what these embeddings and vector database work with is something known as semantic proximity. So similar concepts live close together in the vector space. So what does it really mean to capture a distance between the word ocean and water? Like I know how to subtract 52 minus 27. Okay, that makes sense to me. But how do you subtract ocean and water? Or another example, if I take the word king and subtract man from the word king, but add the word woman, what should this be equal to? Can someone guess in the chat? So king minus the gender aspect of it, man, but adding women to it while keeping the ruler aspect of the king intact. So ruler plus women, a woman ruler, what is it called? How would that even function? Do folks want to like guess in the chat? Queen, right? Exactly. That's exactly right. But those are the types of things, these distance concepts that you can do with embedding based representations of text. And so we talked about chunking, we talked about embeddings, and now we talk about vector databases. So these are the vector databases that store and index these vectors efficiently so that similar content can be retrieved very quickly. Um, so vector database essentially means vector storage and semantic search. It enables both of those things in one go. And typically, some of the popular vector databases are Pinecone, ChromaDB, FAISS from Facebook. It's called Facebook AI Similarity Search, Qdrant. All of these folks are developing vector databases which have which have enterprise level solutions too, as well as open source ones. And so, whenever you are searching through a vector database, it indexes these high dimensional embeddings for approximate nearest neighbor search. And these are some of the examples I talked about. It uses specialized algorithms like inverse vector formulation, hierarchical nearest neighbor uh, search to search through billions of vectors very efficiently. And because it can search very efficiently, we can search within a specific category or recent data using just metadata filtering as well. We have ability to just tag each of these documents with certain metadata in our vector DB as well. And some of the applications of vector stores are really anything from recommendation engines to search engines like Google to language engines to security applications and physics and computational biology and chemistry and so on. So anything that can use text-based information and retrieval associated with that, you can use a vector store there. Actually, not just text-based. You saw you can have multimodal um, input as well, right? So any application which are many that use stuff like that can use a vector DB. One piece that we didn't quite explicitly mention as a concept that is used in RAG or is needed is prompt engineering. So once you retrieve the chunks within from our vector DB and embed them into the prompt to ground the model inputs and reduce the hallucination, what are some of the things that you should keep in mind to do that well beyond just the chunk retrieval? And what you can do is prompt engineering. And prompt engineering in my experience is as much art as science, which essentially deals with optimizing prompts to guide AI models towards generating the responses that we particularly need. And the quality of the response at the end of the day depends on both the LLM and the prompt that you're using. And there are a few techniques for prompt engineering, like there's zero shot prompting, few shot prompting, chain of thought reasoning or chain of thought prompting, tree of thought, and so on. There's also a variety of different ways where you can design a prompt well. For example, the prompt should tell the LLM about the intent, the tone, the structure of the response, the structure of the input and the output, and so on. For example, um, if you create a generic prompt, like create a task manager app that supports collaboration, user should be able to register or sign in. So collaboration on what? What services are you asking for? What is the UI supposed to look like? Make an app such that the users can log in. Okay, which app? What is it talking about? You should see a list of tasks and new ones and make changes when needed. But what is this app about? Is it an e-commerce app, something like Zomato, something like DoorDash? What are we talking about? And so typically when you're talking about creating an effective prompt, this is beyond my examples about chain of thought prompting or tree of thought prompting and zero shot or few shot learning. These are just creating good structured English responses which have clarity, which give LLM the context that you're talking about. Some examples, this is that few shot learning example that I was talking about, or prompt engineering technique I was talking about. Mention certain keywords that are relevant to your domain or the prompt, and the tone that you expect the response to be in, the output response to be in. And again, giving specific instructions helps. Setting constraints about the format, the length, the style requirements, giving some examples on what the output should look like, and then iterating based on all of these things is something that is required and almost necessary in generative AI based solutions. So one question that I would ask you guys is, if you take a pre-trained model, not ChatGPT, not Claude or anything, a pre-trained LLM, and if you ask that LLM this question, I live in Paris, should I carry an umbrella today if I'm going out? Will it do that? Can it do that rather? No, right? As most of you are pointing it out correctly. It's because it's a pre-trained LLM. It doesn't have access to the live weather information for today. So my next question is, how can you make that LLM answer this question? RAG is so yeah, so good question. RAG is not necessarily going to solve this particular question, right? Because RAG is just, I mean, you can append weather-related documents every single morning in your RAG-based design, and that's fine. You can do that, and then it will work. But what about if I want a system that is like live? Like I want to know like right at this instant, um, if I should carry an umbrella or not. One thing that you can do is create agents, right? Where essentially, so what is an agent? Agent in if you want to like have a very simple definition about an agent, it's LLM plus tools. So imagine a pre-trained LLM which has access to weather API, such that whenever a user asks a question about weather, it can go and call this weather API right now and get the weather for a city and a time. And if this LLM has access to something like this, if you agentify this LLM, you can actually get a response for this particular question. So agents are the answer to do that for us. And autonomous agents are essentially these software programs which have ability to understand, make a decision, execute an action, and adapt its behavior based on whatever the user is asking. So, again, a very simple definition is agent is nothing but LLM which has access to tools. And because it has access to tools, what these agentic frameworks can do is create this react pattern. React pattern stands for reasoning and action. That's why react. RE stands for reasoning, ACT stands for action. And what that react pattern enables these agents to do is mimic this thought, action, and observation loop. So just like humans, whenever humans have a question, we think. Based on our thinking, we take an action. Based on our action, we observe how that action produced a result. And if that result is not very good, we go back to thinking and produce a new action and a new observation. And we keep on repeating this thought, action, observation framework because we have the ability to do so. And that is exactly what we are imparting to this pre-trained LLM by giving it access to multiple different tools, such that it can make its own thought, action, observation framework and interact with the environment in that way. So the core components when you are designing an agent is uh, uh, the brain, the essentially the agentic brain is essentially the LLM. Planning is essentially giving the agent enough context about what it is trying to do, enough instructions, system level prompts for folks who are familiar with a little bit of agentic design. Memory, so how much past information should this agent remember? And tools meaning API calls like weather API, cricket news, and sports news, and so on. So that when the user comes in, it can quickly call a relevant tool, see if the answer exists in the memory from the recent past, or do some planning if the task requires planning based on the planning instructions. So what all can these agents do? Agents are particularly useful for complex tasks. So tasks that require multiple steps, like find me the cheapest flight to Paris and then send me an itinerary for a 10-day Paris trip. So that's like a two-step process which has sub-steps within it, right? They require tool. If a task requires tool integration, something like who was or um, when did World War II end is a very historical question, right? Most of the LLMs will probably be able to answer that because that information is in their training data. But something like what is the stock price of Apple? What was the stock price of Apple yesterday? Is something that will require tool integration because you need to connect to an API which has all of this financial information and can get the most up to date data. And then if you want to perform dynamic action, so if the problem is not straightforward and requires certain logic, like reasoning steps to break down a problem and then access this external information, that is where you need agents, which essentially means you need to equip your LLM with certain tools. So um, if this question was asked to an LLM which had access to tools, which we are calling an agent, the agent will understand that two things are needed. One, get the weather information for this city called Paris, and then determine if the user needs to use an umbrella or not. So the agent will use weather API to get weather. If that weather API tool says rain, then typically within a large language models, like the weather API doesn't say anything about carrying an umbrella, right? I mean, if you go, I mean, it's your choice to carry an umbrella or not in the rain. But typically, a large language model will be trained on a lot of text which where it has seen the words like rain, raincoat, umbrella, all of these things living within the same space in that vector db, if you will. And so it will correlate the fact that okay, the weather API did say it's raining, and rain and umbrella have something to do with them. And so yes, okay, if it's raining, maybe I should respond that you will need an umbrella. And so it will generate its final response like so. And so why use agents versus a single stop LLM? So if you have a plain LLM, it's limited to its training data, right? And it's limited to a single prompt. All of the information that you need will be within that prompt. It will have no external actions, and it's useful for simple Q&A tasks. So like if you want to learn about some historical information, a knowledge-based LLM is fine. But if you want to do multi-step reasoning, interact with the external world, extend the interaction with some memory, and make these decisions dynamically, agentic AI is the way to go. Because agents, which are LLM plus tools, unlock these complex workflows that single step LLMs cannot do. And to now that being said, designing agentic based frameworks do have come with their own challenges, and to mitigate these challenges we must appropriately design these systems and use them responsibly. So if you have bad quality data, there's a phenomenon in this data science, machine learning, Gen AI world, which is garbage in, garbage out. If you have garbage in data, the output is going to be garbage. Algorithmic bias, if you train your LLM on biased data, it's going to produce biased responses. You need to worry about how it's going to interact with your existing system and how it's going to scale for performance. A lot of computing power is required to actually create a useful application at scale. At a small scale, it's generally doable. If you want to like scale it, then you have to worry about the cost. And there's of course cost, as I mentioned, cost is a big thing. Understanding what can this particular task be done without an LLM, which tasks within this larger project needs an agentic thing, which tasks can be done by a simple LLM, what are some of the ethical concerns, and creating a continuous maintenance and like a CI/CD type of a pipeline for these agentic infrastructure as well. It takes there's a certain cost associated with it in terms of managing these systems as well. So we have seen some of the critical building blocks for these agents, which enable it to take that thought, action, observation framework is planning. So creating certain prompts where it tells the agent on how to act, enabling it with memory, either short term or long term, so that it can retrieve the context very quickly from the past. Tools, where essentially it's access to multiple different external tools so that it can interact with the external world. And all of these things together enable the action, thought, action, observation framework, and makes the agent a powerful system. So some of the building blocks of agents are again tools and APIs, which are just connecting the LLM to some external world. Some common tool examples are web search, database queries like a SQL tool, some math tool, or a code execution environment, some Twitter API, LinkedIn API, and so on. Planning and workflow is another important piece when it comes to building an agent. So typically agents break down complex tasks into a series of steps and then decide which step to take. And that logic can be designed using explicit graphs or through prompt engineering techniques, or through some complex programmatic workflows as well. And you have certain frameworks which enable us to do all of these things. And we'll talk a little bit about that a bit later. Third is memory architecture. What type of memory do you want your agent to have? Is it short-term in-context memory? Is it long-term memory? Is it shared memory for across multiple different agents? Do you want to store external knowledge and give access to an external DB, like in a RAG, to your agent? And do you want to, the fourth thing is state and checkpointing. What that really means is it checkpointing saves the state of at some of the key steps to a database such that when you restart this agent, it can quickly come back up, and reduce its latency, if you will. And this enables like these long running agents to resume after interruptions or errors or like services are down and not lose the information. Um, Observation and evaluation. So there's a lot of observation and evaluation frameworks in place. So these agentic frameworks have a lot of tool calls that they make, right? Like a user asks an English question that goes to the LLM. LLM decides to call multiple different tools. What exactly happened? What was the input and the output? Which tool was the one that was called upon by the LLM? All of that is useful for debugging, and you have frameworks to set up that observability and evaluation framework. And then safety and guardrails. So make sure that your LLM is doing the thing that you intended to do. Make sure that the input and the output are constructed correctly for the tools that you're calling. If you are scaling this thing, make sure that the rate limits are obeyed, so that you don't incur a lot of API calls and the cost associated with them, and make sure that the scope is restricted. If you are designing an agent that talks about the weather, you don't want that agent to talk about sports news. So, for example, an AI without guardrails might answer questions like, what is the purpose of life? The purpose of life is to blah, 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 have fun and eat food. On the other hand, if you have guardrails in place and this agent is supposed to answer only about travel responses, then it should say something like, I cannot answer this question. So putting guardrails in place is um, is very critical. And within this agentic frameworks, you have multiple architecture patterns coming up. So you have single agent pattern versus multi-agent pattern. Again, remember the definition of our agent. Agent is nothing but LLM plus tools. Single agent is nothing but single LLM plus tool calls associated with that single LLM. Multi-agent system is nothing but having multiple pieces like this. So imagine one agent that talks about the weather. It's an LLM which has access to a weather API. Another agent that talks about the sports news. So it has LLM and access to a sports news. And now it can combine the two things, right? For example, let's say you can ask about, given the sports event today, and the fact that it's going to rain today, do you think what's the probability of this event actually happening? So you can create a multi-agent system that can make a reasonable decision based off of multiple different tool calls associated with different phenomena, right? One thing will fetch the weather. It will say that, oh, maybe it's raining. The other thing will say the match is supposed to happen in the next 2 hours. Based on its pre-trained knowledge, maybe it will know that rain and these sports events don't go well together, and so maybe the match is delayed and something. So that's your multi-agent system. And this is what I was talking about, that reasoning and action framework. LLMs plus tool, which is the definition of agents, these things enable these common agentic patterns, which the reasoning plus action, self-asking, so self-critiquing, LLM can critique its own response, and uh, tool former. So essentially, um, insert certain API calls within the model when needed. And all of these patterns are enable LLMs to mimic this chain of thought reasoning and decision making that humans do when they solve a particular problem. So, right. So now that we have seen these multi-agent, uh, when what's a single agent and what's a multi-agent, typically a multi-agent system architecture would look like you have some planner and an executor. So essentially you have one agent that plans the tasks and other agent that actually executes them step by step. So you have, let's say, the other pattern that comes up is a supervisor worker pattern. So you have one agent that has access to all the other agents, and all of these sub agents communicate to the supervisor about their output, and the supervisor decides which agent to call next. And then delegation and handoff. So essentially, there are some agents where the one agent does its task and hands off the result to the other agent. The other agent does its task, hands off the thing to the third agent, and so on. And then finally, the final agent gets the final answer. Those are the types of patterns that are emerging within the agentic AI workflows. Just like in software engineering, you have patterns like the factory design pattern, the builder pattern. Those are the types of patterns that are coming up in this world as well. And now that we have seen what agents can do and how they think, let's shift our focus from this architecture to implementation. There are a variety of different frameworks that you can use to build agents. Agent development frameworks are software libraries that give these building blocks like tool calling, API calls, memory, planning, observation and evaluation framework, setting up guardrails, and they abstract away all of these things instead of you writing each and every code for all of these things one by one. These frameworks abstract away these things for you such that you can get to your POC very fast. And so um, with these what can you do with these frameworks, and what can these frameworks help you build? These frameworks can help you build code understanding agents, summarization agents, chatbots, integration with APIs, tabular, building an agent that can do SQL and tabular data queries, and so on. Some of the popular frameworks are, so I typically try to bucket them in no code frameworks. No code frameworks is something like this N8N, Zapier, Make, where essentially it's just drag and drop, right? Right? If you like drag and drop certain icons on the board and connect them with edges, that's like, and you write very limited code. In fact, you write no code for simple tasks. That's your no code frameworks. Then there's low code frameworks like Crew AI, and then there's verbose code framework, for lack of a better word, like LangGraph and LangChain. So all of these frameworks essentially do the same thing, where essentially they provide these building blocks for creating applications like these, and they abstract away information like abstract away concepts like these. So right. And so there's different pros and cons to each one of these frameworks. Typically, LangChain is used for a simpler sequential tasks. LangGraph, on the other hand, is good for designing a multi-agent system. Autogen prides itself, I think, in a certain memory management and having a multi-agent architecture, but it's still emerging. Um, Crew AI again is a low-code framework, so you don't have to code every single aspect about the agent, but some of those concepts are abstracted away from you, and so on. But really, which one to choose based upon the complexity and uniqueness of your task. So if your task is fairly straightforward, something like N8N will work very well, because it will have the APIs and the integrations that you need for your well-known non-unique problem. On the other hand, if the problem is extremely specific to you and your company and your specific use case, If you want absolute granular control, maybe LangGraph is the way to go, because it really strips down every single thing, and you can like manage everything at low level. So, right. So choosing a right framework really comes down to, if you like want very fine control and have a very complex logic, as I was saying, LangGraph is the way to go. If it's like a data heavy question and answering session, Llama Index offers like good and fast retrieval for question answering tasks. If you have like if you need a faster setup, and if you have a if you want a low code framework, Crew AI is the way to go. And so these are the types of questions you need to ask when choosing a right framework for the agent. Now that being said, remember that all of these frameworks can be used to build a agentic AI solution for a particular problem. These are just tools, or not tools, but these are methods to get to the solution of the problem one way or the other. So, with that being said, let's quickly go through. We did a lot of talking, but I would like to show you an example of how this will look in action. So, let me see if, okay, let me bring my screen on the right panel here. Okay, can folks see my screen? Okay,
Yes.
great. Thanks.
Yeah.
So, so what we are going to do today is we are going to demonstrate a very simple agent using LangChain, which can decide what tools to call, when to call them, when to execute them, and then produce a final grounded response. You will see like two smaller tools, like a policy lookup tool and a date math tool, a LangChain agent loop that uses these tools, and then we'll also stream the output to show like how these tool calls are made. So the very first thing that I'm doing is I'm just installing some basic dependencies like LangChain, and I'm going to use OpenAI's LLM. So that's why I need the OpenAI integration with LangChain. Um, I'm just making sure that the versions I have installed are compatible. I have set up my OpenAI API key because I want to use their LLM. And now we define our tools. So a LangChain agent can call tools when it needs them, and we define two tiny tools: a policy lookup tool, whose job is to return a short policy snippet from our in-memory knowledge base, and days between tool, which calculates the duration essentially. And the agent will decide when to call which tool. So our imagine we have a database with this information about the refund policy, this information about the cancellation policy, right? So this is like refunds are allowed within 30 days, um, cancellation can be allowed anytime. So if we have a database like this, LangChain and LangGraph give us this method where we can decorate. This is a simple Python function, right? There's nothing that special about it. But the moment you add this decorator or mark this function with this decorator called add tool, you can add these functions to an LLM to make that LLM an agent. Remember, agent is nothing but LLM plus tools. So you can add these functions to an LLM such that those LLMs can actually work with this function. So let's create an agent. So we create a chat model using GPT-4o Mini. We create an agent, and then we explicitly instruct the agent. These are the guardrails. So for policy questions, call this policy lookup tool. For date math, call this days in between tool, and format the output in exactly two bullets. So that's what we have said here in our instructions. We give the tools to our agent, which is this policy lookup function and days in between function. And the LLM that we are using is this uh, chat chat OpenAI GPT-4o mini model, right? So that's our agent that we have set up here. So we have used the create agent function from LangChain that takes an LLM, takes tools, and then takes the instructions about this agent on how it should perform its tasks. And so now when we ask this agent a question like a user purchased something on 1st of December 2025 and requested a refund on 23rd of December 2025. Check your refund policy and tell me if they're eligible. Use tools, reply exactly in 2 bullet points. So the very first thing that will happen is we are talking about a refund, right? So take a look here. The LLM went and said, okay, I need to make up a policy lookup about refund. So I'm going to make a tool call for this thing. Uh, Once you make that tool call, it came back with this result that the refund policy refund is allowed within 30 days. The next tool call that I need, okay, so it has some information. After 30 days, the refunds are not provided and blah, blah. The next tool call that it needs to make to answer this particular question about eligibility is this duration, right? And so it's going to say, okay, let me call this days between tool. So let me take these 2 days and actually do the date math. So between 1st of December and 23rd of December, it's 22 days, right? That's the answer associated with this particular tool. So the answer associated with the policy lookup tool was this, answer associated with the days between tool was this. And now given with all of this context, now the model can generate a response. The customer is eligible because it falls within the 30-day policy window. And then what you're doing is you are just instead of grabbing all of these intermediate results, you can just grab the uh, last answer, this answer as the result here. And that's really a very quick RAG based demo that I wanted to show and how easy it is to set up using LangChain. And as you can imagine, you can keep on adding more and more tools. You can obviously make this database a lot more realistic, a lot more complex. You can maybe connect it to a vector database as well. But those are some of the things that I wanted to show for the setup today. Um, and give you guys a glimpse into what the system can look like and the capabilities here. Now, that being said, I do want to say that what I covered today in an hour and 10 minutes is something that we would cover in more than 10 hours worth of lectures and classes and live demos and notebooks and in a lot more detail. So the pace at which I went today is not representative of the pace that is typically covered in our live classes, but hopefully this gives you a glimpse of the types of material that we show. And with that, I think over to you, Niyati.
Yes, there was a key takeaway slide if you just want
Oh,
to.
yes, there's one more slide actually. I'm sorry, let me just share
No worries.
that thing. Yeah, so can you folks see my screen again? So, right. So again, some of the do's and don'ts are this again goes back to that philosophy of our prompt engineering. That same thing applies to agents as well. We start with clear task definitions and success criteria. We instrument these observation and evaluation frameworks such that we can enable tracing and logging. We don't let agents get stuck in an infinite loop. So we set some explicit stop conditions and we validate all the inputs and outputs for safety, just like we did right now. And some of the things that you should avoid is create agents that can do simple tasks very well. Don't create an agent which is very complex. let's not create an agent which has access to the weather API, the sports API, Twitter API, and some breaking news API, all within just one function. The good way to do that would be create separate agents for all of these things, such that they can do one task well. Um, Neglecting persistence for long running tasks, skipping retry logic for certain small failures and error handling, ignoring guardrails such that your LLM can produce whatever responses and bypass some logic about security is something that we should avoid. And so, some of the key takeaways that we can take away from this small example is, even though this example was small, I think the patterns are still there, which is these building blocks matter, right? We talked about tools, memory, planning, observability, guardrails within this small example of ours. Patterns like these enable complexity. So, like this reasoning and action pattern, self reflection pattern, multi agent pattern unlock sophisticated reasoning capabilities. Which framework to choose? I showed you how LangChain can be used for like somewhat simplistic solution. Depending on your use case, you can choose LangGraph or Crew AI or Llama Index for what application you're building. And then, uh, while keeping an eye on production readiness and scale, you can make a decision about how the infrastructure would look like when you deploy these systems in production as well.
Yes, that's my cue to jump in. Thanks
Yep.
a lot, Sudhir. While you were taking the session at lightning speed, I have tried to answer as many questions as possible in the Q&A, but we have over thousands and thousands of participants. So I'm sorry if I didn't get in time for to answer questions. I'm still not in the session. Sudhir, I know we'll be moving on, but we'll have another instructor. So I'll keep answering the questions. But Sudhir, firstly, thanks a ton for doing this in the middle of the night for you. It's I think around 3:30-ish or 3:30, and I'm
Yeah.
so glad you could take out the time. Uh, Very engaging session. We had a lot of questions. A lot of questions. Just I think one question that which is topical, a lot of uh, people were asking was something around vectorless DBs, and I've tried to answer that from a precision angle versus depth angle. You can go ahead, maybe just answer that one question, and people can also take a break now. And you can I will take 10 minutes from all of you for the next 10 minutes, but I'll let Surhid answer this particular question first.
So,
So there was a question on vectorless DB. Like we have vectorless DBs now. What is the efficacy of those versus the vector DB that you were talking about?
I see. Okay. So vectorless DBs essentially are systems that bypass your high dimensional vector embeddings and semantic search in favor of some efficient retrieval methods like structured data filtering, keyword search. Like, I mean, if you folks know that BM25 algorithm, which is like this hybrid algorithm that maps keyword search and semantic search, you have uh, vectorless DBs which run these algorithms in the backend. And so some of the advantages of these vectorless DBs are that they eliminate the need to maintain these embedding models, and so they reduce the computational cost and provide some higher precision for specific exact match queries. And so if you have some domain specific task like financial or legal where there's a lot of jargon, right? Like exact keyword matching and deterministic results are more important than conceptual similarity. That's where I think vectorless DBs shine. On the other hand, if you still need a semantic solution where this unstructured data is living and you want to create this semantic similarity thing, um, uh, I think vector DBs are still really the way to go for now. Hopefully that answers the question.
Yep. Uh, you can, if you want, I'm going to start sharing my screen. So a couple of questions that were getting repeated, I will answer those. But Surit, if you want to just stay back, so some of the questions you want to just type out the answer to in the Q&A, please feel free to do that.
Okay.
Everybody was asking for recording. currently we do not share recording of our sessions, but we will eventually share the slides as well as the Jupyter Notebook link in our Discord and Slack community or via the email, right? So you will get it. Recordings are not available as of now, but I think a lot of you are asking that, and I wanted to answer that to everybody. What I'm gonna do is share my screen, and a lot of you are talking about something that is going to be very, very relevant uh, for most of you here, which is I don't have a structured path. Like, what do I do, right? What should be my next steps? You were enjoying the session that Suhrid was taking, and you were asking a lot of questions, engaging with him. But what next, right? So, firstly, what next is we have a second session coming up today, so that's next. Day two, which is tomorrow, we again have the two sessions that you can see in front of you. In the session that's going to start in another 10-15 minutes, we are going to build our first agent. If it's the first agent for you, or you're going to see one uh, using MCP integration. Tomorrow, we are going to orchestrate like a multi-agent system and see that to deployment by the end of session two tomorrow, right? Uh, so what are we going to, how am I going to answer the question of what is the process of moving beyond these foundational concepts? Sudhir did mention that these concepts that we are taking you through, we have tried to sort of squeeze them in over the 2 days, but in our courses, we go very, very slowly so that even if you're starting off your journey as a technical professional who wants to get AI enabled, you're able to cover everything. These are weeks of basically concepts that we are trying to squeeze in over 2 days and have it delivered from the horse's mouth, so to say, which is people like Surhit who work in one of the top names, tech names, and build these AI systems. So by the way, how can you're already doing all of the things that you may have, glanced through over the over in this slide, which is you're asking a lot of questions. I'm trying to answer most of them. Okay, so be a little patient with me, but we'll also have the instructor answer those questions. We have an AMA session towards the end. Okay, and join the community, the Slack community and the Discord community links that we have shared. You can start networking with people. A lot of you wanted to chat with each other. Go ahead, do that over there. And currently, the Q&A section is open for you to ask your questions, right? So I'm going to have a special person talk to you while you take a break and take a water break or food break, whatever you're taking at this point of time. Uh, I'm going to have a video from Brian, who's our co-founder, who's going to talk to you a little about AI, right? You may be a beginner, but have a look at this and you'll relate to most of what he's saying. I'm going to pause after like 2-3 seconds of playing so that you just tell me if it's audible or not.
AI is no longer the future.
Were you able to hear that? Audible. Great, great, great. Thanks, folks. Okay, so let's hear him again. AI is no longer the future.
AI is no longer the future. It is here, it is the now, and it is the skill that every single person in technology needs to be on top of if you want to survive and also thrive in the next many, many, many years. This AI wave has unlocked.
I'm sorry, I think.
AI is no longer the future. Want to survive and also thrive in the next many, many, many years. This AI wave has unlocked unprecedented opportunities for all of us. If you look at all the hiring over the last few quarters, you see that all the growth has really come in AI roles and now increasingly so in AI-enabled roles. Far more importantly, the compensation that we are seeing here, going up to $1 billion in some cases, is unheralded. It's unprecedented and nothing that we've ever seen before. We ourselves at Interview Kickstart are constantly seeing our own alumni who are AI-enabled or have AI and ML skills getting offers, and in many cases are $300,000 to $400,000 more than their peers simply because they have the AI skill set. The challenge, though, is that AI is moving at warp speed. It's moving so fast that it's very difficult to figure out both where to start and how to pick a path that is customized, or to use a word often used these days, fine-tuned for you. That's where we at Interview Kickstart come in. We have built a career acceleration platform that helps you turbocharge your career with AI skills. We've been doing this over the last 12 years, and I've already worked with over 25,000 working professionals from all domains in tech: software, product, data, ICs, managers, and the entire like. Our approach is unique. We believe that the frontier of AI has moved to the world's best companies and the world's best AI labs, which is why we bring together a platform of over 700 instructors, all of whom who come from the likes of Google, OpenAI, Meta, Anthropic, and other cutting-edge AI companies. Everything that we bring to you is designed, developed, and delivered live by these professionals. And so they bring their frontier lived experience to every single classroom. We also believe that the world has changed. It has moved from an era of passive learning to now active building. And so in each of our programs, you will get your hands dirty. You will build AI projects, all oriented on helping you build an AI portfolio, because that is what is required today if you want to turbocharge your career. Finally, we realize that there is no one-size-fits-all in AI, and AI really needs to meet you where you are at. And all of us are at different levels, have different experience, have different backgrounds. And so we offer a plethora of courses that is completely flexible. They range from 3 months, 6 months, 9 months, 12 months, spend more than a year as well, based on your career goal. They're fine-tuned for every domain. We have 18 to 20 domains that we cover. We have separate courses for ICs, separate courses for managers, and we have versions in pro code, low code, and no code. Bottom line, we want to meet you where you are and work with you step by step as you up level to building a fabulous AI career.
Yes. So a lot of you would have related to what Ryan was saying in the video, right? That a lot of us have moved from only looking at AI roles as what is present in the hiring market, but also now what we increasingly see is AI enabled roles. So you can be a backend software engineer, you can be a technical program manager, you can be an EM, engineering manager, and all of these roles can be AI enabled too. While some of these can obviously get into AI intensive roles, and we'll tell you how. But most of us in the audience will relate to, if we haven't started our AI journey as of now, or are looking for a place to start it in a structured manner, we might be facing these 4 stages of AI denial. Number one being AI is moving too fast for me, right? So where do I start? Where do I when, at what point am I joining the bandwagon, right? Will I understand everything? There's too much out there, right? That's the second one. Yes, there is too much out there, but what's relevant for you can be picked up and can be learned. My job is unique and so safe. AI is kind of everywhere at this point of time in different industries, and there were, some questions on how is Agentic AI developing in healthcare, banking, all of these, right? So it's industry agnostic, or it's job agnostic at this point of time. Even non-tech roles, it's present and picking up in, right? And some people feel I will have to kind of down level my skills. No, you basically layer it with whatever skills you have. Most of our tech professionals who are our learners, they have like 50 to 70% of skills that are needed, the technical skills. And when they layer it with AI, it just kind of amplifies everything, right? So where do you what's the typical journey like? Now at Interview Kickstart, we do believe that all of us, or all of our learners, they have some they will need something that is customized, right? We do not treat a backend engineer similar to a TPM, similar to a data engineer or a data analyst, or a front-end engineer. All of you, like Ryan said, have individual paths in AI upleveling as well as interview preparation. These two are the major aspects of what we offer, that we teach you the right AI skills, and we also prep you for those top tier tech firm interviews and how to crack them. So till now, maybe right now you might be using LLMs or co-pilots to basically increase your productivity at work. But what is slowly happening, and most of you might be experiencing it already, because we are in today is 21st March 2026, and we have moved forward so much in this AI era already, that we are now in the transformation segment, where people are building complex AI agents to basically scale their projects, scale business impact. They are building on top of existing models. They are building new ML models also. Okay. And our next speaker is a great person to sort of talk about these topics ahead, and he'll touch upon some aspects when he's taking you through it. But we have gone from augmentation or productivity only sort of pitch to a place where we are transforming using AI. Now, what kind of roles are people targeting? For example, like I said, most of these can make you AI enabled in your domain that you're already in. So anything you know at this point of time, all will come to use. You do not have to start from scratch. You basically just need to layer your current skills. Okay, so you can become an AI enabled software engineer, a product manager, an EMTPM, all with AI enablement. If you want to build on top of advanced ML models or build new ML models, you can get into AI specific or intensive roles, okay, or ML roles as they are called, ML engineers or data engineers or DevOps learning, MLOps and all of that, correct? So, now your next question would be, that's great, good information, but is there a path that I can actually take? Because most of the people, we have done many such sessions, and thousands of you who have joined. Currently, your question is, yeah, I want to become, say, an AI enabled engineer, or I want to become an ML engineer. How do I do that? How do I exactly start? Because everything is moving so fast, right? So we have three specific roadmaps for you. All of them are interview preparation enabled, because we do believe outcomes is what you're looking for, and we are happy to help you there, right? So the first one being, the first two parts for if you want to go into agentic AI, layering agentic AI in your current role. First is transformative Gen AI and interview lab, where we always also start from foundations in Python. If you already know it, you can skip the first couple of weeks, but Python is where we start. We get into foundational generative AI and agentic AI, start building with these things. All of our programs are project based or project led. Okay, so whatever you're learning, you're also building. And whom are you building it with? You're building with people like Suhrid. You're building it with people like our next speaker, Justin Joseph, who they already have a lot of experience. They are already doing scaling these AI ML models in the biggest of the names possible. So they give you everything right from the epicenter where it's happening. That's transformative Gen AI. Okay. Then we have something very portfolio oriented, that if you have Python understanding and if you have some knowledge of AI, for example, you have dabbled in AI agents, little bit also, you can explain to someone what is RAG. You can build a portfolio straight up with one of, we have tied up with an industry partner where we provide you 4 capstone projects in healthcare, in BFSI, in SCM, and e-commerce, right? So you build a portfolio and show it to the next recruiter or even your current manager to get that jump in your career. This also is an interview prep enabled program. And I'll explain you what do I mean by interview preparation lab. But our third program is for people who want to get into AI intensive programs, basically become an ML engineer primarily, right? So that's the flagship machine learning program, where we go from classical ML, modern ML to deep learning, to even we'll cover concepts on agentic AI over there. Again, everything project-based learning, hands-on, and whatever we are trying to squeeze in these 2 days, it's spread over hours, turning into weeks of modules where you go deeper into a concept. Okay, you can interact with the faculty in the class. You can ask your concepts. You can do one-on-ones with take a technical coaching. All of that is available. So these three parts: get AI enablement with transformative Gen AI and interview lab, build a portfolio in agentic AI, and crack interviews with the interview lab, and get into ML specific roles with flagship machine learning. Right? I know it might be a lot. If these you want details of these three programs, you can always talk to our career and program advisors. They will be very happy to help you, to give you a very personalized roadmap. Just talk to them in general about what's happening, whether you go ahead, not go ahead. We can figure that out later. But happy to talk to you and understand where you are. So, in a nutshell, if you want to become AI enabled, the middle program is for you. If you're unsure of anything, just start here. We are going to use your already present skills and build from there. If you want to build an agentic AI portfolio with our industry partner and use cases of what that industry partner has built for different companies, if you have Python knowledge and AI knowledge already, then choose the Agentic AI Career Accelerator and Interview Lab. The third is, if you want to transition into an ML role, you can choose the third option, which is the machine learning program. All of the durations are also present. Anywhere between 6 to 10 months is what will take you generally to complete any of these courses. These are the prices in front of you. These are differential pricing as per your domain. So we have 18 domains, the background that you come from, what domain you come from, all of the pricing is based on that. Okay, these are not final pricing. We have scholarships running as of now. And we also have EMI options across. Okay, so don't get bogged down by this. Obviously, every structured program, there is a certain price to it, but we always also know that you have your responsibilities, etc. We can build out a roadmap for you and help you out over there, right? We also have a 50% refund policy in some of these programs. If you want to know more, talk to your program advisor and career advisor for that. Okay. Now, I've been talking about, customized roadmaps for all of you. What do I mean by that? And what and what all do we cover? Like, what kind of domains do we cover? We cover all of these 18 to 20 domains that are in front of you. So in software engineering, we cover backend, front end, full stack, iOS, Android, test engineers, all of that. In management, for example, management domain, we cover TPMs, PM Tech, engineering managers, and in data, we have data engineers, data science, ML engineers also, right? So you can pick up any of these. We'll customize the projects that you do in the AI up leveling, and also we'll properly customize the interview preparation bit for you, right? What do we cover? When we say interview preparation, what do we cover? We have live sessions on DSA and SD, depending on the domain that you come from. Obviously, we also have domain-based interview modules. So what do I mean by that is that if you're a front-end engineer versus a TPM, your interviews are going to be very, very different, right? So we teach interview modules as per the domain that you come from. In some of the engineering first roles, DSA and SD are common throughout. For EMs, we also have leadership preparation rounds specifically. And we have about 15 mock interviews that you can take with our faculty like Surhid, Justin, and instructors that are going to join us tomorrow, and have a real-time feedback session with them about how did you do in the mock, what can you do better. You get a personalized feedback approach from them. Okay, these are actually the hiring managers who are hiring at this point of time in their teams, in AI ML teams, and they'll tell you exactly what works. We help you in resume optimization, LinkedIn optimization. We give you coaching to crack those salary negotiation rounds, behavioral rounds, and we have about 200 hiring partners in India. We also give you job referrals wherever it is applicable and relevant. Okay, so that brings me to the end of what is Interview Kickstart all about and how can we help you get better, do better. If you have any questions, I'm going to launch a poll right now, and you can let us know if you want a specific, a sort of roadmap from us, and do you want help in terms of choosing the right program for you? Happy to do that. So I'm going to launch a poll. You can go ahead, answer that if you would like to connect with us for further consultation, right? And yeah, with that, while you guys are answering, I'm going to hand it over to our next instructor also, who's going to take the session 2 for us. Justin, very happy to see you again. Thanks for joining in. And I know the second session, a lot of people were waiting for this particular session, by the way, because while Suhid very nicely covered a lot of foundational theory and foundational concepts, they were eager to build the first AI agent. For many of them, it's first. So, we are happy to have you to take them through it. Okay. So, as I mentioned at the start of the session itself, the first session itself, there are some free resources that we have for you. Some of you might have already gotten it. If you haven't, then join the Slack community or the Discord community. The links were shared in the chat. We'll share it again as soon as I hand it over to Justin. But go ahead, go through these free resources. These are great starting points for all of you, right? Again, just repeating for some people who have joined just now, and giving our old folks, old audience folks to, come back to the session before we start the session too. This is applicable to all the tech professionals that's mentioned and more, right? If you're an engineer, any type of engineer, software engineer, uh, product managers, technical program managers, EMs, it's applicable to all of you. After the end of day 2, you're going to probably get curious and do an AI pilot at your workplace and try something out, right? We'll be super happy to enable that for you. Now, without much ado, I'm going to open the floor for our next speaker, who is Justin Joseph. I've repeated it many times already, but he's a staff AI engineer at Analog Devices. He works in Ireland. So again, joining us and giving us time. From there, thanks a lot. He's a BITS Pilani alum, and he's worked on in various AI roles in the last over a decade almost now, and worked with some of the top names like Siemens and Analog Devices, right? So over to you, Justin. Thanks a lot for joining in again, and I hope you guys have a great session. I'm going to keep answering as much as possible in the Q&A, but I know you'll do an AMA towards the end.
Thanks, Nidhi. Hi, everybody. Good afternoon. So it's currently 8 a.m. here, and it's the second day of spring. There is sunshine, and it's a beautiful day out there. So, hi. Let me just start sharing the screen. And yeah, Shivansh, I saw your request. Do we have a 5-minute break? You can actually take a 5-minute break. When you come back, nothing would have been changed. I would just give my introduction right now, and within the 5 minutes, you would be back. So let me just share the screen. Yep. So let me start with a quick introduction about myself. I'm Justin Joseph, and I'm a staff AI engineer working for Analog Devices at their European Research and Development Center in Limerick, Ireland. So it's been only 10 months or around a year since I moved to Ireland. I've been working in Bangalore before that for Siemens. So I've been working in the industrial automation domain, or in other words, creating and building AI agents, or not just agents, anything, computer vision models, natural language processing models, invoice extractors, worker safety use cases, anything and everything that can provide business use case to industrial automation, both in Analog Devices and in Siemens. And I've been predominantly working with robotics AI these days. You might have heard of the term physical AI. I'm just writing it here. Yeah. You might have heard of the term physical AI. I've been working with physical AI predominantly these days. In other words, we are currently attempting to make robots or robotic systems autonomous by using the agentic AI and using LLMs in order to perform reasoning, and also couple that with the vision-based models for it to visualize the environment and then make decisions accordingly as to what to do, what to perform, what is the optimal way to perform the requested action by the user, maximize the productivity, etc. So we have been working on models that we call as vision language action models. The idea is these robotic systems perceive the environment using the cameras or the vision. Then it communicates with each other, or it communicates or reasons within itself using natural language, or it even communicates with the user using natural language. And then based on the vision and the language, it decides what actions to perform. And that is the A actions. And these are the vision language action models. And we are currently last week we were having a demonstration at the NVIDIA GTC at San Jose. So this is what we are currently working on. We are working on agentic systems. RAG obviously is used by these agentic systems in order to use additional information in the form of documents that we have in order to answer the queries, or in order to perform the thought process, or in order to solve our problems faster. So I have done around 9 years of experience. So I've been working and studying side by side. So with respect to my educational credentials, I have a master's degree in data science, a PG diploma in applied statistics, and a bachelor's in industrial engineering. So let's get to the next part. So in today's session, we will be, oh, just a quick thing. I see that we have around 1,500 participants here. So kindly excuse me if I'm not able to take up all the questions in real time, because if I start taking up the questions in real time, I think as of now, that would be the only thing that I would be doing. So, the size of the cohort. So kindly excuse me. Let's get started with some of the basic idea of the LangChain fundamentals, the current limitations, not the current limitations, but the limitations of LangChain, where LangChain works, which is mitigated to a great extent by something that you have heard of, which would be LangGraph. Sorry, which is LangGraph, as well as the inception of something called model context protocols in order to mitigate a lot of these limitations. And we will be discussing what MCP is, what the different components of MCP is, and then the main aspect, the hands-on MCP implementation. And I think we should focus more time on that rather than the theoretical slides, because building the agentic systems or building the MCP implementation is the objective of today's session, rather than walking you through a lot of theory. And then let's first, let me just give you a prerequisite. Where is it? Yeah. So what I want you guys to do is, I want you guys to go to the Node.js website. Here, I'll just post it in the chat. And I want you to download, let me just respond to everyone in the chat. So I want you to download the Node.js version and install it on your system, whichever is compatible for your system. Mine is a Mac OS, so I chose this. And you can just go for the latest version in whichever system that you have. And the rest of the things, you can keep it the same. So it'll give you the set of steps to install this. Let me, I will show the previous slide. Give me a moment, because I have not moved away from the slide. I'm just saying that if you can parallelly install this by following the set of steps mentioned here, then it would save a lot of time and you will be able to work with me during the demonstration, because installing Node.js is what's going to take some time. So if your system is Windows, you can just toggle it to Windows and you could just follow this installation steps. And once you will be running the Node version and the NPM version, it will show that your installation is complete and successful. Now, okay, so let that happen parallelly. I have given the link in the chat. Is the version 24.9 or fine now? Absolutely. Any other versions are also fine. Yeah. All right. And it depends on your internet connection. As far as I know, internet connection in India was much better than most of the other places in the world. So it's a fast internet connection. So please go to Claude AI and download Claude. So I have Claude here. Give me a moment. Let me share the complete screen. Apologies for that. Yeah, I hope you can see my complete screen. So I have downloaded Claude here. So similarly, I'm also expecting you to download Claude at your end. Oh, by the way, what happened? Yeah. All right. So once you have downloaded Claude, I'm not talking about the Claude CLI. I'm talking about the Claude application. Okay. And is there any other requirement that we have other than the Node.js and the Claude? I don't think so. Yeah, that would suffice. Yeah. All right. Let's get back. So you were asking about the slides, right? The link to the cloud. Yeah, give me a moment. See, I did tell that the internet connection in most of Europe is not as great as that in India. So that's why it's a bit slow. Here it is in the chat. Okay, so you can download Claude as well. Parallelly, let's continue. We were talking about the LangChain fundamentals, the current limitations, and we didn't start. Yeah. So it is showing me to download Node.js using Docker. You don't have to go for Node.js using Docker. So where is it? Here. Which is your mission? Windows? You can just go for this set of steps here, which is mentioned. You don't have to go for Docker, right? You can just go for the default one that comes up, which is chocolatey. Or you don't have to go for, or if you want, you can go for Docker. It's absolutely fine. But if you go for Docker, whether you will be able to access it from the cloud application, I'm not exactly sure. Okay. Try to go with this if possible. Yeah. Let me get back. Docker has a bit of limitation, like if you're installing it within a Docker file, within a Docker container, I don't know how it's going to be. Okay, no worries. You can go with Docker. I'm sorry. You can go with Docker as well because currently after running this, it will be installing, and after that, my question is whether this would be inside a Docker container. If it is inside a Docker container, I'm not exactly. Okay. Oh, okay. Satish, thank you very much. You installed with MSI. Okay. So the thing is, I didn't go through the Windows one because I was just busy setting up everything for my current system. So apologies for that. So next time I'll take a look at that. Okay. Cloud link is not helping. Okay. Give me a moment. Yeah, it takes you here and you can just click on the download button, right? Yeah, you can select chocolatey Vimal and you can work with that. That would work. Yeah. Sorry, Mantra, I missed your message. 22.16.0, that's absolutely fine. The version is fine. Yeah. The Cloud link is good. Thank you. Thanks for confirming. All right. So you go ahead with that. So let's go with the slides. Is that fine? Do we need to enable developer mode in Windows to download Cloud? To download Cloud, you won't need it. To install it, you won't need it. And after that, are you asking about the developer mode inside Cloud? Or are you asking about the developer mode of the Windows machine? I don't think you would require that. Can someone please share the link? I can do it. Give me a moment. By the way, Niyati, is there a way to pin this link?
I can
Or
try to pin it.
yeah, if there's a
Can you just,
provision, I don't know whether it's
can you
possible.
just, I'll copy it anyway and I'll try to pin it. Thanks.
Okay. Yeah, Mayur, it can be done with a free cloud account. Even mine is a free cloud account. You can see on the bottom left, mine is a free plan. Only two things are needed to install as of now. Yes. Okay. All right. So installing Cloud on personal laptop is safe. We generally give it permission to access your files, but as far as my system, so you have to explicitly give it permissions to access your local folders. So I remember when I give it folder that we have for today's demonstration. One moment. One particular folder that we have for today's demonstration, it asked, can I access this folder? That means it has only access to this folder. At least from a Mac machine's perspective, I know that it has only access to this folder because I explicitly gave it access to this folder. I'm not exactly sure about the Windows part. What about Node.js? I installed it. How to access it? You don't have to access it. You just have to verify the installation by doing these two commands, the Node version and the npm version. Is Codex also fine? No, we are actually having the demo with respect to the Cloud Cloud application. So we will be connecting the MCP servers and everything to the Cloud, which will be your MCP client. All right. How to limit it that way in Mac? Did it request access to? So by default in Mac, it does not give access to all the folders. So only in the second part of the demonstration, where we create our custom MCP, would we require to give it access to even that folder. So you don't even need to worry about anything right now. It's showing black screen. Okay, will you share the instructions later after the course? Yeah, I can do that. No issues at all. So one moment. Okay, I'm driving. Cool, it's fine. Claude.dmg is downloaded. However, what I need to do next? Just double click on that. Just double click on Claude.dmg. Give me a moment. So this is Claude.dmg. Just double tap on it. And then this pops up this. And then you have to just drag and drop it into the applications. All right. And then for me, it's going to ask, do I need to oh my God, did I? No. Usually it'll ask, do I need to replace it? Since I already have it. So for you, it is going to work that way. Okay. So is it required to install Claude in local? Can't go with the web version. Why we went for the local version is that I want you to implement a custom MCP demonstration as a second part of the demo. And for that, you will have to provide it access to certain files as well, which is why we went for the local one. Yeah. You can stop. I can stop what? Okay. Linux Claude doesn't work here. I'm very sorry. It doesn't work there. I'm not okay. I'm really sorry in that case. I was actually expecting that everyone would be using either Windows or Mac. So okay, cool. Can you please share the links again? Got disconnected. Yes, I can share a number of times. If there is a way to pin this, Pratyush, you are saying npm version does not work. Did you finish the installation? Did you finish the installation? Can you press the stop button? What stop button are you referring to? Do we need to install Cloud Code? You don't need to install Cloud Code, just the Cloud application would suffice. How do we check the Node.js is installed in Mac? Just use these two lines of code, node-v, node space -v and npm space -v. You would be good, both in Mac or Windows. Then what else? I think we can begin now. Yes, please. Let's go with the slides. Thanks for that. Okay. Newer version, the versions are absolutely fine. Okay. So since we have a huge cohort, we have to resort to the slides. I'm very sorry about this. So let's continue. Okay, cool. All right, perfect. So let's talk about LangChain or the agentic systems or the understanding of agentic systems. So first thing, I know all of you would have different levels of understanding of what LLMs are, what agentic systems are, what RAG is, what LangChain is, what LangGraph is, all of this. So in order to help you understand it in the easiest way, when you talk about agents, how do you differentiate an agent from a large language model? How do you differentiate an LLM from an agent? Or what is your way of understanding this? Kindly keep the errors aside because we can, if we get some time, we can possibly look at the errors after discussing some theory. All right, something that has the ability to take action on behalf of the user. That's a good definition. Usually, that is the definition of conventional definition of agents. You are absolutely fine. You are absolutely right. LLMs plus tools. That is also a good way to talk about agents. So, just one quick question: the ChatGPT web application that you use, or the Gemini web application that you use, are they agents or are they LLMs? Yeah, some of you are saying they're LLMs and some of you are saying they're agents. So the right answer is the web application that you use from Google Gemini here or ChatGPT are actually agents. Why? Because these models which they use in the backend are the LLMs. And these LLMs, okay, so if you remember, I don't know how many of you were using ChatGPT in 2022 or when it released. So at that time, when you ask a question to ChatGPT, like what is the weather at my location today? ChatGPT might tell you, I cannot provide any real-time information. I am trained with data only up to September 2021, if I remember right. So many of you would have faced this. And at that time, ChatGPT was just an LLM. These days, you ask this question to ChatGPT. I ask the weather at my current location, and it will give me the weather at my current location. Why? Because it has access to certain tools, or it has access to certain APIs like the weather.com's API or the Google search, which it can perform in order to find the weather and then bring it back. And then the LLM is going to nicely wrap it in a proper sentence format and give it back to you. So, like some of you said, the general definition of agents can be LLMs plus the tools. Now, an advanced definition of agents can be advanced, not the advanced definition, but these days, agents are mostly focused on not just responding to your queries, but rather performing actions on behalf of you. Like, for example, if you want to plan an itinerary or if you want to plan a travel, if you have an agent that can assist you with that, this agent should go and search for the flight tickets and book the flights for you, search for the hotels and book the hotels for you. And it has to plan an itinerary. And then, based on all of your requirements for the flight, hotel, and travel plans, as well as your preferences, it needs to create a curated, customized itinerary. So, it can be a multi agent system where one agent will be focusing on orchestrating all of this, like a manager. And there would be specialized agents where the specialized agent number one can focus on booking the flight tickets autonomously. Specialized agent number two can focus on booking the hotels autonomously. And agent number three can focus on what? Flights and itinerary. Agent number three can focus on building an itinerary. So, which is why we were saying that some of you were saying that agents are things that can perform decision making for us. Yes, agents are aspects that can automate work for us, yes, to a great extent. But the general definition of an agent can just be the LLMs plus the tools wrapped as an agent. So the brain of the agentic system is the LLM. And when we talk about agents, we should be focusing on the reasoning aspect of the agents, because a traditional LLM is just text in and text out. So this was the traditional LLM. But these days, the current LLMs have a lot of reasoning capability. That means they're trained using the concept of reinforcement learning. In other words, they are incentivized or they are rewarded for performing the correct thought process. So even if it does not meet the end goal during the process of training, even if it provides the correct thought process, or if it has 5 steps to do, if it does 4 steps, it is going to be rewarded for that. And it is not simply text in and text out. So when you ask Gemini a question, so especially if you use the pro models, you would be able to see the thought process. So I don't know how accurate it is going to be, but let's give it a try. So if you switch to the pro models of Gemini and you ask a question, what is the weather at my location now? I don't think it's going to be accurate, but let's see. So here, it is going to perform a thought process, and it is even going to perform a Google search. And then based on that, this is the thought process that you see here. So the thought process is defining the parameters. So the weather query, the specific location, and the current time. And then it, for some reason, it mistook that I'm in Dublin. I'm not in Dublin. Dublin is like 2 hours away from here. And it gives me the weather information of Dublin here. So the weather information is of Dublin is correct, but I'm not in Dublin. So that is there. But at least I just wanted to show you the thought process that underwent this, just like a human thinks. So when a human sees this, the first question that the human asks is, what do you mean by my location? And it figured out Dublin, even though it is slightly incorrect, it's fine. And then the second question that the human would ask is, okay, I need to fetch the weather. So probably I would use some weather API or Google search or something like that in order to fetch it. And that is exactly what this did. So this is the reasoning that underwent this, or the thought process that underwent this. And what you see here in Fred is the solution or the response by this agentic system. So I just wanted to mention about the reasoning power. There are multiple mechanisms for reasoning, by the way. The most popular mechanism, at least some of you might heard of, is called the React framework. React is reasoning plus action. And if you are interested in learning more about it, So there is something called React, which means reasoning plus action. So the idea of React is that your agentic system has like the Google search that you saw there, like the weather API, like some database parsing, like a calculator. All of these are examples of tools. So your agentic system has these tools, and your LLM is aware that these tools are available. Now you ask a question to to the agentic system, and the LLM parses this question, and the LLM triggers the reasoning process. And the LLM says that, okay, I have these tools. So based on the user's question, do I require to use any tools? And the LLM will make the decision. And based on the decision, the agent triggers the tool. And the tool could be your Google search tool here, like we saw in the weather API, weather scenario. And that is the action. The triggering of the tool is the action. And once the action is triggered, the tool receives the input query. And the tool says that, okay, this is the output. So the input query for the Google search was, what is the weather at this particular location? And the output from the tool was, this is the weather. And the LLM receives the response back. And the LLM reasons once again, do I have everything required to provide the output to the user? And then the LLM says, yes, I verified it. I have it. And then it reformats it and provides the output to the user in the way which is best suitable. So this is the case of reasoning plus action. It's not as simple as it looks. It has multiple loops because first it will reason, it will perform an action based on the action's output. It will reason again. Sometimes it might have to trigger another action. So it might go in loops until it gives the final response to the user. So if you're interested in knowing more about the reasoning plus action, if you're interested in knowing more about reasoning plus action, there is a good YouTube video for that I came across the other day. One moment. There is also a simple implementation of this. So here in the chat, I've just mentioned it. If you're interested, you can go through it. All right. So now let's get back to our core agenda. I just explained what agents are. Agents enable the LLMs to make decisions or to take actions. And then the agents are beyond your simple text generation. That is the primary thing. And now, did your previous session cover RAG? By the way, let me just look at the chat. Did your previous session cover RAG?
Yes.
Okay, perfect. Okay, that means you now know what RAG is. So, do you also have some idea of LangChain? What LangChain is? So, no worries. If you do not know what LangChain is, okay, that's also great. Okay, it's a framework. It's a framework for chaining. Yeah, it's a framework for chaining. You're absolutely right. So you have an LLM, you have multiple tools. And if you want to create a sequential process out of all of this, you can use LangChain where you can create something that we call as a chain. So LangChain is built on, okay, wait. So LangChain is built on something that we call as chains. So these chains are a DAG-like concept. So some of you might know what DAG is. So if you use Power BI or something like that, you might know what, oh, that's DAX. So DAG is, if you are used to graphs, you might know what DAG is. So in other words, these are chains or these are tightly coupled so you have components and they are tightly coupled in order to form something that we call as chain. So it's a DAG-like concept. And the idea is that, see, for RAG, what all did you chain? So your LLM was there in RAG. What else was there? Your retriever was there. So the retrieval mechanism of the most similar documents. And then what was there? You might also have the system prompt. And all of this chained together into a sequence of calls will be your RAG mechanism. So RAG mechanism can be created using LangChain by chaining the different components or chaining the sequence of calls that we have in order to create our entire application. So the directed acyclic graphs, yeah, you're right. I did not want to go into the terminology a lot. So which is why I stuck to the superficial overview, because huge cohort here have different levels of understanding. Some of you might know all about what I'm talking about. Some of you might have no clue, which is why I'm trying to keep it as simple as possible. All right. So LangChain is built on chains, and you chain the different components together in order to create your sequence of calls. Now, what is the limitation of LangChain? So by now, many of you might know that LangChain is not predominantly used in the industry these days. We generally use something that we call as LangGraph over LangChain. And we also use certain additional components on top of these, like MCPs, in order to mitigate some disadvantages. So we will be talking about all of that. But what is your level of understanding on that? Single agent. Mhm. So multi-agent. So no worries. If you do not have an understanding also, it's fine. So the primary limitation of LangChain is that um, the chains are quite strict and they are a hard-coded sequence. So you might say that for the RAG architecture, I don't know what architecture graph the previous instructor used. So just use a RAG architecture. It's a boilerplate RAG architecture that we'll be looking at. So in this particular RAG architecture, I'm not going to explain it again due to the interest of time, but yeah. But this is what you learned probably in one of the earlier sessions, as far as I understand. So you have the user's query coming in. So the first sequence would be that the user query should be converted to an embedding using the embedding model. Now, externally or separately, during the offline process, separately, you would have converted the documents into embeddings and stored them in the vector DB. Now, first thing is you would trigger the retriever. What the retriever does is, so second thing is you would trigger the retriever. So the first thing was the user query being converted into embeddings using whatever embedding generation model that you use. It could be BERT, BERT, or sentence BERT, or any of the other models. Now, these will be converted to an embedding, and now the retriever, what it does is the embedding of the user query will be used to perform a similarity check on the embeddings which are resting in the vector DB. The embeddings resting in the vector DB are embeddings created from the data that you have. Now, this triggers the retrieval of the most similar documents. And that is the second thing that we were talking about. First thing was converting the user query to embedding. Second chain is triggering the retrieval. The third part is creating an augmented query, combining the user query, the documents retrieved, and the system prompt. And then the LLM is triggered, and you get the final response. So it's a sequential approach that we are doing here. And LangChain is quite good for the sequential approaches. But in real time, are these approaches actually sequential? Or in real production level applications, are these approaches sequential? Look at the weather API, a scenario that we just took earlier. So based on the user's query that is coming in, is it going to be sequential? I asked a query in a different format. I asked something totally different. So it is not going to fetch my location. It is not going to fetch my weather in the same order. It might be totally different. So that is what we were saying, that LangChain works quite good for sequential approaches, but almost all the production related scenario or the production grade scenario won't be a sequential approach at all. You will have multiple tools, and based on the reasoning, the agent will have to trigger the correct tool or the proper tool in order to fetch something. And based on that, it'll have to modify the reasoning, and then it'll have to conduct the process in a meaningful way, where it is not chaining. Rather, a graph-based approach would work better for that. A graph-based approach means you have different nodes. These nodes can be, you can these nodes as tools, or the LLM. All of these would be a part of this graph. And these nodes of the graph will be connected to each other using edges. And edges define the relationship between the nodes. Now, based on the different queries that are coming in, based on the requirements that are coming in, the system can decide to trigger whatever tool it wants based on the relationship between the LLM and the tool. So it can understand what is the relationship, and based on that, it can decide to trigger whatever tool it wants in a dynamic fashion. So we are not restricted to the chains. And that is exactly what uh, frameworks like LangGraph has an advantage compared to LangChain. This is a superficial level of understanding. This doesn't mean that LangChain cannot be used for building dynamic agents. It can, but still there are a lot of limitations there as well. So I just wanted to keep it superficial for now. Okay. So yeah. So Priyal, that's a good question. Why do we need LangChain? AI agents are smart enough to figure out what order. Yes, you're right. But how do we build the AI agents? So it's like, I don't know whether you worked with deep learning or machine learning. So for deep learning, we use a framework called PyTorch or TensorFlow. For machine learning, we might use a framework called Scikit-learn. So your question can be, why do we use PyTorch? Aren't the deep learning models capable of doing it by itself? Yes. But in order to create the deep learning model, or in order to orchestrate the deep learning models, you require a framework for which can significantly help you with building the applications and spinning them up compared to writing every low level code. So frameworks like LangChain or LangGraph, what do you say? LangChain or LangGraph helps you just write the high level code and not delve into the low level code in building this agentic systems. So it makes your work and your life easier. That's the idea. So just like, so if you remember back in 2015 or 2013 or something, we used to almost always work with C++ or Java or something like that. And then Python came. So Python is a high-level programming language. Your C or Java is more like a low-level programming language. So high-level programming language is easier to work with, faster. No, it's slower, but easier to work with. So the concept is that compared to low-level programming languages, the customization capability might be a little less, but it suits almost all of the use cases. So we generally go for Python, especially people who are new to coding prefer Python because it's easier than C or C++. Similarly, building agents from scratch compared to building agents using frameworks, I would always prefer using frameworks because uh, for building production level systems as well, I need proper structured code, proper structured classes, proper structured functions, and all of that, rather than delving into the low level code and meddling with that. All right. So, what is LangChain? So, LangChain is a framework for developing applications powered by language models, which were your agents that we were discussing. And these are created to simplify the process of building LLM applications and helps connect LLMs to external data sources and tools and all of it. So another downside of LangChain is that if you have n number of tools, okay, if you have 10 tools, then you will have to write or you will have to create the connectors. So you will have to create 10 different connectors for the 10 tools. So tool number one can be your weather API. It might give you a response in a particular JSON format, like saying that location is this, date is this, weather is this, um, weather summary is this, lowest temperature is this, highest temperature is this, so on and so forth. And another tool could be your Google search. It might return the results in a totally different format. Another tool will be your calculator. That too might return your results in a totally different format. So depending on the tools that you have, you will have to write your own connectors manually. So that is a pain because when you have a production level system, you will have a lot of different databases, you will have a lot of different tools, you will have a lot of different systems to connect to if required. So writing custom connectors for all of this is a pain. There is another primary downside with respect to this. So you might be able to think of it. So if you have a number of tools and if you have to manually write these connectors, what is another downside of this? Can you think of it? Abstraction. Um, abstraction, yes, because you will have to, mess up, not mess up, but you will have to, meddle with all these connectors and you will have to do all of this yourself. It's a pain. Yeah, I understand. Compatibility, scaling. Yeah, all of you are right. So compatibility is a problem. Scaling is a problem. Number of connections is a problem. Time taking, no uniformity. More than that, I was expecting something. Managing, maintainability. Exactly. So tomorrow, the weather API folks are going to change how the API provides output. They change the output format. My production system, my agentic system is going to crash because my agentic system expects the weather API output in a particular format. Tomorrow they changed it. I didn't know. I was sleeping. My production system failed. And then I had to fix it. Now, the number of tools and number of databases and everything increases. That is where the complexity lies. Different changes are happening at different points. your production system keeps on breaking. So this is where the primary disadvantage of LangChain lies. And that is why you need a unified connector. And we'll be talking about the unified connector during our demo, which we call as the Model Context Protocol. So let's go ahead. So we also discussed that LangChain uses a sequence of calls to LLMs or other utilities like your Retriever, your weather tool, your calculator, all this. Now, agents, we also discussed what agents are. And now, quick question. A standard LLM, okay, a vanilla LLM. Does this vanilla LLM means a raw LLM without any modifications, does it have the capability to have a context? Or does it have a capability to keep context? Or does it have a capability to have a conversation state? That is my exact question. No, it does not. You're right. So it does not. So I talked to the LLM. Hi, how are you? And it says, I'm great. And I asked the LLM, what are you capable of doing? It says that I'm good at predicting the weather. Then I asked the LLM, so what is the weather at Boston? And it returns me the weather. And then I see that there is a cyclone in Boston. And I say that based on the weather that you gave me about Boston, I noticed that there are some anomalies. That means the cyclone. I'm referring to the cyclone. And would that affect New Delhi? So this is my question. So I asked the LLM this particular question, and we are talking about a raw LLM. And this LLM has no context or no idea as to what happened before. And then it might end up hallucinating, or it might end up coming up with a totally different anomaly and not the tornado or the storm that I'm talking about. So the idea is we require something called conversation states, or in other words, we have something called memory systems, and that keeps short-term context as well as long-term context. So short-term context means in the current conversation that you're undergoing, it keeps a track of the current conversation, and based on how the conversation is evolving, it will try to update the current context. And there is also the long-term context, which is more like a persistent storage. So the best example of this is you can just go to ChatGPT and you can ask ChatGPT to create a biodata of yourself. Don't give any information. So if you have been using the ChatGPT application or the account since some time, I'm pretty sure that it is going to give you a very accurate description of who you are. You might be surprised. I was surprised. So it will say that you are an IT professional or whoever you are. And it might say that these are your preferences. It might say that these are your food preferences. It might say that these are your hobbies. These are your, what else? This is how your personal life is going. This, if you have discussed finances with ChatGPT, this is how much you earn. In other words, it might even end up creating a very good matrimonial profile of you. So that is what we are talking about, long-term persistent memory. Okay, so I hope you understood by now. And then you have the prompts. The prompts are the structured inputs to the language models that you're going to give. So the prompts could be at least some examples. Where was it covered earlier? Something like system prompt. So this is the easiest example of prompt. So user prompt is already there, which you give it to the LLM. Your question. So was system prompt covered earlier? Okay, system prompt is not covered earlier. It's simple. The idea of system prompt is that the user prompt is what the user asks the agentic system or the LLM. And the system prompt is a set of instructions that you as a developer is going to fine grain into the system. So you will explicitly say that your agentic system. So in the past, I have built an agentic system that can support the sales team of my organization in my previous organization. So my system prompt was that behave like a seasoned salesperson and provide adequate recommendations by factoring in the user's requirement along with asking them about their budget constraints and their personal requirements. Then other than that, use very professional language. Do not use expletives. Do not engage in personal conversations. Try to keep it as professional as possible. All of these rules, regulations, restrictions, all of these things will be in your system prompt. So if you remember, in the RAG architecture framework that I showed you, the user query is coming in. the most similar documents from your corpus of documents are retrieved, which can help in answering the user query. And then there is also something called system prompt. These three are clubbed together in order to create your robust prompt. So the system prompt is a set of instructions that is given to the agentic system in order to fine tune how it, not fine tune, in order to control how it behaves, in order to control how it should not behave, and all of that. So your ChatGPT, your Gemini, all of these are system prompts, by the way. We don't see it, but there are system prompts. How do you think it can easily identify? So when you ask how to dispose a dead body, ChatGPT doesn't support you with that, right? How do you think it can figure out? How do you think it can it can understand that it should not answer this based on the detailed system prompt that is given to this, and also because of some kind of training. That's why I'm not going into that, but system prompt plays a major role. Just wanted to mention that. Okay. So LangChain is immensely popular because of its simplicity. And whatever is very simple has a downside. When it goes to production, you are going to face the backlash of all of that. And for agentic AI development as well, you can use LangChain. And there are modular components of LangChain. At least some of you might be aware of the modular components of LangChain. Like, for example, if you want to create a reasoning action, I already mentioned at the start of this session. So if you want to create a reasoning action agent, the LangChain has something called the create react agent. It also has something called create tool calling agent. These are functions that I've used when I used to work with LangChain tool create tool calling agent when I was working with LangChain. So I remember this. So yeah. So it has large ecosystems of integration with various tools and databases, but just that you will have to take care of the connectors. And it has built-in patterns for common AI application needs. Like, for example, in order to keep a track of your memory, LangChain has something called conversation buffer memory. Conversation buffer memory. So you don't need to create a memory from scratch. That means you don't need to write the low-level code. You can just call this function and you can just pass the conversation or the user input and the output of the system to it, and it is going to store these in memory for you. So a lot of things like that. And even for prompts, LangChain has a lot of support for prompt creation. Like, for example, it provides something called prompt template, so that there are some placeholders for you where you can give some placeholders in order to create a structured prompt. So you can say that if your application focuses on performing financial review of organization, so your system prompt can be perform the financial review of this organization, and the organization can be a variable name, and the variable can be fetched from the user's query. So prompt templates can be used. There is also something called chat prompt template, where you can give some set of instructions to LangChain saying that this is how you should be behaving, and you can consider these examples. So LangChain has a lot of existing components or existing patterns or existing functions that you can reuse to build agentic systems, is what we are talking about. But the issue is the chain, the limitation of the chain, and the issue is the problem with the connectors, and there are many other issues as well. We'll be talking about that. So LangChain use cases, or it need not be LangChain. You can use LangChain, LangGraph, or any framework that you're comfortable with in order to do all of this. Okay, so you can use this to build document analysis and QA systems, chatbots, reasoning systems, data extraction and analysis, agentic systems that take actions on behalf of users, like the trip planning agent that we were talking about earlier. So current limitations of LangChain, and from this we will be pivoting into MCPs. All right. So the first thing, we actually discussed some of this limited scalability. So rather than going through all of them, let's superficially discuss the limitations first. So the first thing, the limitation is the N by M integration. The N by M integration means, we already talked about this. So if you have 3 different AI frameworks and you have 5 different data sources, how many connectors will you have to build? 3 AI frameworks, 5 different connectors, 15 N by M. So 15 connectors you will be supposed to write. Now, in a production system, this number is going to increase. And writing it is one thing, maintaining it is the pain. So this is the primary disadvantage of LangChain. And this disadvantage will be mitigated by something that we call as model context protocol. So this is one limitation. Let's just look at some of the limitations that will be mitigated by MCPs, because my focus of today's session is to introduce you to the concept of MCPs and to build something using MCPs. So MCPs, one moment, yeah, versus LangChain is what we're talking about. Because LangChain has a lot of disadvantages. You can explain it for days. So let's just focus on those disadvantages that can be mitigated significantly by MCPs. So your N by M integration is the first thing. And the next thing is the context window blotting. And what do you mean by context window? The idea of context window, some of you might know, but many of you may not. Context window means your LLM, you might be using the GPT-3, GPT-4, anything. Every LLM has a context window. That means, let's take an example of a simple model, not current models, a simple model. If the context window has a limit of 5,000, it means that it can only process 5,000 tokens at a time. For understanding of tokens, you can perceive tokens as words for now. The actual meaning of tokens are not words. So for now, you can perceive tokens as words. So if the token limit is if the context window limit is 5,000, then it can only process 5,000 tokens or 5,000 words at a time. That means if you pass a long essay consisting of 10,000 words, it won't be able to process it. Or in other words, it will only process the 5,000 words and it will give you an output. So your extra context is never processed. So why we mention context window blotting is that in LangChain, if your agent has access to 50 different tools, every tool. So first thing, how does the agent know that it has these tools? And how does the agent know what the tools are capable of? We use something called tool descriptions. So we use something called tool descriptions for this. So every tool has a tool description. Every tool has a description. It's a textual description of what it does, what it is capable of doing, etc. Now, your LLM should decide which tool to trigger or whether any tool should be triggering by looking at all of these descriptions. You have 50 tools, 50 different descriptions. Look at the number of tokens that are there in the description alone. Huge. Now, your LLM should process these tokens in order to make a decision as to which tool to trigger or if any tool should be triggered in the first place. The problem here is when you trigger the LLMs, you will be mostly using LLMs like OpenAI's, Gemini, etc., or Claude, all of this. There is a pricing to all of this, right? And when you burn a lot of tokens, your pocket burns, or you will be spending a lot of money, and you don't want this. Now, another thing is not just about the tool, and your tool is called, and your tool gives you back a huge data set, for instance. Now, this huge data set is fed to the LLM once again. Context. You're burning money. You're using your LLMs like anything. So even if you're hosting it on premise, your latency will be affected. So your context window will be significantly blotted, and you have a lot of tokens that go to waste. And one example of that was every tool has multiple descriptions, and you will be processing all of this. Another example of that is what if tools give a big data set or a big essay for you, a big data set, then once again, a lot of tokens will be burned. So this is another downside of your LangChain. So we'll be talking about MCPs and how MCPs mitigate all of this. We'll talk about that later. Now, you also have security vulnerabilities to a great extent in LangChain. Security vulnerabilities. Because do you remember me talking about the fact that you require to create 15 connectors or N by M number of connectors? Now, the problem is you will have to secure all of these connectors as well. Now, any kind of attacks on these connectors can result in someone else gaining access to your agentic system, which you do not want. So security vulnerabilities is a pain, and there is no standardized method, or there is no standardized way to ensure that or to enforce that there won't be security vulnerabilities. And then limited ecosystem, or you can perceive it as an ecosystem lock-in. So why are ecosystems popular? Certain ecosystems are popular because it has a lot of capability to do a lot of things. Like, for example, the Apple ecosystem. So the convenience of the Apple ecosystem is immense. So you can drag and drop files from your iPhone to your MacBook to your iPad, all of this. So and this is just one example. So the ecosystem, if it has limitations, it is going to be a pain. And when you start using LangChain, I told you that LangChain is extremely limited or restricted to chains. So if you want to create a dynamic system which is not limited to chains, it is going to be a pain. And LangChain has a lot of limitations with respect to what it can do. So it is extremely framework. It is extremely framework focused, and whatever limitations are there in this framework is going to be a pain for you. And also, one more thing, migration is also going to be a pain. Like, for example, you want to move your system to something like Llama Index. Okay, if you want to move your agent logic to something like Llama Index instead of LangChain, then the problem is you will have to rewrite all the tools from scratch to fit the new framework. So you have to rewrite all the tools or connectors or whatever else that you have written to fit the new framework if you want to migrate something. All of this are primary limitations of LangChain with respect to dealing with tools. We are not even talking about dealing with something else. We are just dealing with tools or databases. And that is where MCP is predominantly required. We'll talk about MCP soon. So these are the limitations that we are interested in because we'll be talking about MCP soon. So the general limitations of LangChain we discussed earlier: limited scalability, complexity in the integration, and single turn stateless operation. So stateless means by default it is not providing any memory or anything. You will have to incorporate additional memory to it for it to factor in the state, or for it to understand what happened before, so that it can provide it can continue processing by keeping proper context. Now, the scaling problem you already talked about. So different LLMs use inconsistent function calls, or different LLMs or different tools use different function call formats. And when you switch the LLMs or when you switch the tools, you cannot use the same connectors. So you will require custom handlers for each LLM. And you can see this example here. This is the format that, oh, this slide, okay. All right, wait. Yeah. I just wanted to show something. Yeah. So this is the format that OpenAI uses. And that format is quite different from the format that Llama or Gemini uses. And that is quite different from the format that Claude uses. So I just wanted to showcase you this. And this is just from LLM's perspective. Similarly for tools as well. So the scaling problem is there for tools as well from the perspective of LangChain. And from an integration complexity perspective, give me a moment. So from an integration complexity perspective, I'm not going into all of the details here. From an integration complexity perspective, you have a lot of implicit dependencies. So you have a downstream component that trusts an upstream component. And if the upstream component is going to make a change in the way the output is provided, then everything else is going to fail. So that is where the chains are going to break when encountering unexpected outputs. So if an upstream component or a tool changes the output format, component changes the output format, changes the output format. And also, there are a lot of other disadvantages. Like, for example, the LangChain language is predominantly, heavily uses, I don't know whether you have used this. So for different chains, to combine the different chains, we use the pipe operator. So when we use the pipe operator, so we'll say chain 1 chain 2, so on and so forth. This is how they are chained together. So it uses the pipe operator. For linear logic, this is fine. But for branching out logic, this is going to be a pain. So that is another disadvantage of LangChain from an integration perspective. Now, from an error handling perspective, LangChain does not have error handling capabilities on its own. So it has some functions like with fallbacks, for instance. I don't know, you might have seen. So it has some functions, but very limited error handling capability in LangChain. And you will have to write your custom error handling logic everywhere for every single thing that you will have to write it. So it's going to be a pain because anywhere you miss something very small, your application is going to break. And how many number of times are you going to patch this, or are you going to fix this? So that is the disadvantage of using a framework like LangChain, and rather you would require a more robust framework like LangGraph, for instance. And even with that, handling tools is going to be a pain because you need the custom connectors, which is why you require a unified integration mechanism like model context protocol, which we will discuss now. So the integration complexity. So I'm just talking about if it is expecting an output in a particular format, in a particular JSON format. If it gets another output, another JSON format as the output, then it's going to fail or it's going to throw an error. So yeah. Now, if you want to incorporate reasoning in LangChain, you will have to provide custom logic for each of the reasoning step. So you won't be able to use reasoning directly by pulling some existing function or anything, but rather you will have to use your own custom logic. And there is no standard approach for planning across multiple tools, which we already discussed. And we have to program the reasoning logic explicitly for each scenario. So all of these are going to be a pain when developing multi-agent systems or production level systems. All right. So if this is just an example, if you want to look at it, the idea is that, so if we ask for weather conditions, in order to mention the weather conditions, it requires the user's location, it requires to check the weather forecast, and it requires to provide the recommendations based on the forecast. Now, if you want to build a simple React agent, the reasoning plus action agent in LangChain, then you need to first define how to implement location fetch, how to implement a weather fetch. Now, for these tools, you will need to create your own classes. Now, after that, you will have to create a custom prompt explaining the reasoning instructions, how it should reason. So, given a question, it should ask what the location is. It should ask what kind of weather recommendations do you prefer. All of this should be provided as external prompts. Multiple examples of this have to be provided for it to replicate something with respect to reasoning. Now, that is not the end. The model's output, so not the model's output, the tools output, for instance, each of this is going to have its own output format. So you will require output parsers, custom output parsers for each of this. Now you have to combine all of this yourself, and then you have to implement the agent with the explicit reasoning loop. Now, any kind of change in the API or any kind of change in the output JSON format, everything is going to crumble like a house of cards. So that is the integration complexity scenario. Now, the stateless challenge, you do not have a state by default. You will have to incorporate additional state. So in LangChain, you will have to provide a manual context tracking. You will have to provide explicit memory configuration, like for example, uh, the conversation buffer memory that we talked about earlier. You need to provide separate context for each of the tool. All of this is going to be cumbersome. And an ideal approach means all of this is going to be automated or unified and built in. So it shouldn't be a pain for the developer. So these are the primary disadvantages of LangChain in general, but we talked about some of the disadvantages which can be mitigated by using something that we call as MCP. And what are MCPs? We'll come to that. But before going into MCPs, let me just stop here. I've been going on a monologue here. I know that we have a huge cohort, which is why I could not take up the questions before. Yes. So please ask your questions that you have. I'll be able to take up 5 or 6 questions, nothing more than that. So Niyati, thank you very much for supporting with the answers in the chat.
Yeah, I'm trying
Please.
to do my best, but I'm sure my answers are not as great as yours. So
No worries at all. Yeah.
but
The thing is,
yeah.
the maximum number of participants that I've handled is around 500. So now we have around 3 times of that. So
Yeah.
which is why I did not engage in
Yes,
a
yes.
Q&A, because it will be just a Q&A session after this then. All right.
Correct.
Yeah, questions, please. Please explain the stateless challenge. Yeah. So stateless means, I told you, LLMs means text in, text out. So you are asking follow-up questions about something. If you ask it to a raw LLM or a vanilla LLM, it does not know what happened before. So it won't be able to answer based on that. So that is the meaning of stateless. Now, if you want to incorporate state into LangChain, you can absolutely do it, but you will have to ensure that the context of the conversation is tracked manually, and you will have to explicitly provide memory configuration saying something like, so for example, in LangChain, we have something called conversation buffer memory. This is the easiest example, which stores the previous conversation, the input from the user, the output from the system. So it stores all of this input, output, input, output, input, output. So we need to explicitly configure all of this for the different LLMs or for the different agents that are there inside the application. Now, you might also have multiple tools. Now, you will have to keep the context for each of the tool. Like, for example, when you're calling a tool, you will be providing certain context. Like, for example, the weather API. You will be providing the location, you will be providing the time, etc. These contexts also have to be stored separately. So all of these individual context tracking or individual memory configuration, you will have to take care of it. That is the meaning of this. How LangChains know what output format will be? It doesn't know. We have to give it. So for each of the tool, for each of the individual components that it is going to interact with, it doesn't know the output format. We have to manually say that this will be how your JSON output format will look like. And for some reason, if the developers who are handling that API make a change there and the output JSON format is changing from today onwards, my system is going to break because my system was expecting the output format in the previous way. So please show the MCP versus LangChain slide. I did not go into the MCP versus LangChain slide, but I was saying that these are the disadvantages of LangChain that MCP can mitigate. That's all. So I did not talk about what MCP is. So without that, I will not be able to tell how these are mitigated in the first place. All right. So
Justin, one interesting question from Avinash in the Q&A section. I can see you're going through the chat. Just wanted to highlight one question.
okay.
So Avinash Pandey has asked this question. As we move from linear pipelines in LangChain to autonomous decision systems in LangGraph, how do we ensure that the model's reasoning path, not just the final answer, is reliable, auditable, and safe in high-stake domains?
So we have a concept called guardrails. So we use guardrails in order to ensure that the model's response is not the model's response, the agent's response is commensurate to what we expect. So there are a lot of guardrails, something as simple as, so for example, for some reason, if the agentic system decides to go overboard or beyond our system prompt, and our system prompt says behave professionally. And for some reason, the agentic AI system decides to not behave professionally and decides to throw a couple of expletives into the conversation. You do not want it to reach the end user. So you use something called guardrails in order to uh, process the end output, and before it reaches the user, you have to block it, or you have to say that your guardrails have to it could be simple text classification. It could be looking for certain keywords. It could be looking for certain kinds of phrases based on similarity. So all of these you can do in the guardrails in order to ensure that the responses are up to the format, or responses are commensurate to what you're expecting before you hand it over to the user. All right. So we are not going into guardrails as of now, but the term is guardrails. You can keep a note of that. A profanity check. Yeah, profanity check is just one example. So profanity check could be something, hallucinations could be something, it could be not responding to the conversation based on the data provided could be something. So many checks can happen for the guardrail mechanism. Yeah. Okay. So guardrail is not a RAG. Guardrail is a mechanism that we use to ensure that the agentic system provides responses in the format or in the way or in the decorum that we expect it to. Okay. Error analysis has to be done manually for LangChain. Yes, we have to do it manually for LangChain. So the guardrail will be based on inner query to handle exceptions or something. So guardrails is just a general term. How you implement it is totally up to your use case. So whether it uses any inner query, whether it uses just the output response, all of this totally depends on the use case that you're building. And you can even have guardrails for each tool responses if you want. So all of this totally up to your application that you're building. So error analysis is significantly automated for LangGraph. So error analysis, there are a lot of predefined functions or predefined mechanisms that you can use for error analysis in the case of LangGraph. So can we use all of this discussed in N8N? Why go for LangChain or LangGraph? What about the cost? So N8N is easy for us to have the UI based implementation of agentic systems. But when you have a production level system, when you have to keep it in production across multiple users in a scalable way, that is where N8N is going to burn your pocket. I'm not sure about the scaling capability. I have not tried that, but I'm pretty sure that it is going to burn your pocket compared to using something like LangGraph. Google Opal versus N8N, which one is better? I have not used Google Opal. So I'm pretty sure, and I've used N8N, it's quite good. I have not used it in production, although. Yeah. Guardrails can be prompt as well. Yeah, guardrails can be a combination of your classical machine learning models. It can be prompts, it can be some other kind of rule-based mechanisms as well. So it can be a combination of all of this. Oh my God. In Q&A, I see that there are like 99 plus questions pending. So probably after that, um, uh, I can take a look at the questions. Okay. So just wanted to address a few questions right now. Now coming to MCPs. Okay. So we just covered these slides. Yeah. MCP. So all right. So the new generation LLMs that you see have a lot of reasoning capabilities within itself. So I was telling you that compared to the old LLMs, so compared to the LLMs that you had before, the LLMs you had before purely focused on a certain kind of task known as next word prediction. So given a question, it has to predict the next word. Then using the question and the next word, it has to predict the word after that. So this was how LLMs used to work or used to be trained conventionally. But these days, LLMs are trained using a mechanism that we call as reinforcement learning. At least some of you might be aware of reinforcement learning, RL. So the idea of reinforcement learning is that it is like a kid learning to walk. So when the child learns to walk, the people who love the child cheers the child when the child attempts to make baby steps. And it is not like the child is congratulated only when the child fully walks. That is not the case. That is reinforcement learning. So every attempt to reach out to the correct response, that is rewarded in the case of reinforcement learning. So if it has to perform a 5-step reasoning, if it provides 3 steps accurately, then there is a reward associated with it. And if it makes only 1 step, then there is a reward associated with it. And if it incorrectly makes the first step, there is a penalty associated with it. So that is the concept of reinforcement learning. And using reinforcement learning, LLMs these days have learned to reason quite well. So compared to the older variant of LLMs, the current LLMs have native reasoning capabilities, can perform model-driven decisions. So during the process of training, a lot of this training also uses the reasoning capacity. So it has scenarios where it has access to multiple tools, multiple databases, etc., where it has to perform model-driven decisions. That means the LLM has to decide what decisions, or what tool, or what uh, data to pick. So these model-driven decisions have made it capable of performing a lot of reasoning within itself. And then they are also adaptive to a great extent. So the current models have a lot of reasoning. The models means the LLMs have a lot of reasoning capabilities within itself. So we need to tap it. And in order to tap it, LangChain is not the best place. So LangChain was quite good if it was just simple text in and text out. But now that the LLMs have reasoning capabilities, we need to tap it. And that is where we need to use, we can also make it use a lot of these tools that we have. So once again, the issues of LangChain, the N by M connectors issue and everything is going to come up here. So the built-in agentic reasoning of the LLMs make it capable to perform step-by-step reasoning. I already mentioned that. Now, the models understand when and how to use the tools more effectively. Yeah. And there is a deliberation process. That means, in other words, we call it reflection. Reflection means the LLM attempts to produce an output, and that output is critiqued by the LLM itself. And this reduces hallucinations, and this improves the decision quality. And the multi-turn tool interaction. It means you have multiple tools in the reasoning action loop. It performs a reasoning, and then it decides to trigger a tool. The tool provides an output. Based on the output of the tool and based on the goal that it has to attain, it decides that, okay, another tool should be called now. Then that response is taken. And based on that, the reasoning is improved, so on and so forth. There is a multi-turn tool interaction that's happening. And in the case of LangChain, you would require the manual orchestration loops or the chains. And in the current scenario, you should not be going for it because it should be dynamic. You should not be saying that after this, go for this, after this, go for this. That is not how it should be. It should be an autonomous decision-making scenario. So, in other words, it tries to mimic the natural problem-solving patterns that human has. So, yeah. So these things I think we already covered it. Like depending on the response of the tools or of the human, it has to adapt the behavior accordingly. And also the contextual continuity and memory. So they have expanded context windows. So the current LLMs have much bigger context windows. That means it can even store the entire conversation history within itself, so that you don't need to manage external, what do you say, external history for this particular LLM. So we can tap that as well. Now, similarly, the tool outputs and also the conversation history coexists in the same model's working memory. That means the model has proper knowledge of whatever it faced until now, if we decide to tap the model's working memory effectively. So you don't have to write everything there. Now coming to MCP. So we have this very intelligent models now. The problem is still with the connectors aspect. Now, just like HTTPS, MCP is a protocol that standardizes how your LLMs communicate with the tools and communicates with the databases, tools and databases. And this communication is managed by the MCP protocol. So we will discuss as to what MCP is and how MCP works. But before that, earlier, your mobile phones, some of them used to have the micro USB port. Some of them used to have the fancy charging ports for the different brands of mobile phones. And Apple used to have its own lightning port, so on and so forth. So everything, if different mobile phones are different connectors. And this is even before around 2010. If you look at around 2010 or before that, almost every brand had its own connectors. It was a pain. So when USB-C came into existence, the USB-C unified this process of connection. And that is exactly how MCPs work. So MCPs came into existence and became the single protocol that we use for communication between the tools and the LLMs, or the databases and the LLMs, in both directions, so that you don't need to write your custom connectors every single time. So that is what MCP mitigates. And when you have a unified system, what is the advantage? Scalability. What is another advantage? Maintainability. What is another advantage? Lesser chances for errors to pop up if any changes happen. So all of this, MCP is going to help you here. All right. So MCP bridges the gap between advanced models and real-world applications. Yeah. And it standardizes how applications and tools communicate with LLMs and creates a universal protocol for AI interactions with data and services. So 2 days back, I had an interesting discussion with a learner, and they asked, if two agents are there, do they communicate using MCPs? They can communicate using MCPs. If agent number 2 is perceived as a tool by agent number one. Then it can communicate using MCPs. But generally, unless the agent number one is an orchestrator or a manager agent of agent number two, we don't use that. So if you want these two agents to be independent and not as a sub-agent of one, then you use something called agent-to-agent protocol and not MCP. So just wanted to highlight this. So there is MCP, there is A2A. A2A is the agent-to-agent protocol. You can try reading about it if you want. Okay. Now, before MCPs, you had the different tools. Each of the different tools had to be connected by its own connectors to the LLM. Now that you have MCP, oh, sorry. Yeah, now that you have MCP, oh, one moment. Yeah, sorry. Now that you have MCP, the MCP acts like the universal communication protocol for the LLM to communicate with all of these tools. So instead of having one individual connectors for each of the tool to connect with the LLM, you just need to connect these tools with MCP, and MCP is going to be connected to the LLMs so that the individual connector requirement is mitigated to a great extent. So this is the concept, or this is the idea of MCPs. Now, yeah. Let's just superficially look at the different components of MCPs, because once we look at the different components of MCPs, we can get started with the demo in the interest of time. Yeah. So the components of MCPs. All right. So if I'm building an agent, okay, and this agent is supposed to automatically review and merge the pull requests in a GitHub repository. So this agent automatically, this is just an example that I'm taking so that I'll be able to explain the components to you. Automatically reviews and merges the PR, the pull request, in GitHub repo. Okay. So from this context, we'll be talking about the different components in MCP. The first component is your MCP host. And the idea of MCP host means that this is the application where the AI model lives and operates. So the AI model lives and operates in the MCP host. Now, in this particular scenario, the PR auto merging scenario, your application, the application that you're building is the host where your AI model lives. So your application is the MCP host. And we'll be talking about how all of these work with each other. Now, this application contains your LLM, your chat, your GPT or your Gemini or whatever it is. And your LLM inherently decides whether the PR is to be merged by reviewing all of it. Now, contains the LLM. That is the first component, your MCP host. And the second component is something that we call as the MCP client. Now, the MCP client, this manages the one-to-one connection and the communication with something that we call as MCP servers. So in our context, the MCP client is the background process that we have inside this app, inside this auto merger agent that translates the AI's expectation to get the PR data into a standardized MCP request. So the idea of MCP client in this scenario is that um, it's the background process inside your agent and the responsibility for this is to translate uh, the PR, the get PR data into a standardized MCP request. So you have the background process inside your agent, translates get PR data into a standard MCP request. MCP request. So things will align more when we first finish each of the components, and then when we say that how they behave with respect to each other. Now, the third component is your MCP server. And this MCP server is the standalone program that sits between the MCP client and the actual data source. So it sits between the MCP client and your data source. Now, in our example, we would run a GitHub MCP server. And why we run a GitHub MCP server is that, GitHub MCP server. And the GitHub MCP server does not contain any LLMs. What it does is, it understands the GitHub API, it handles the authentication there, and it translates the MCP request into GitHub actions that we have. So the GitHub MCP server, what it does is, it does not have any LLMs. Your LLMs are there in your MCP host, and your MCP client resides in your MCP host, and then communicates with the MCP server. So what you're having here is, you will raise a PR request. Okay. Now, there is a webhook or something that informs the host. So the PR request, once it is raised, we'll take a different color. So the PR request comes to the host via a trigger. And this trigger can be a webhook or something like that. Now, your host is triggered. Now, the host knows that the pull request has been opened. Now, next thing, your host asks the client to fetch the context about this PR. So let's give a number, PR request 123. Now the host asks the client to fetch context on PR number 123. Now, the host is where your LLM is residing. So the LLM made the choice in order to ask the client to fetch the context. Now, what does the client do? The client the client is there, the data source is there. What exists between that? The MCP server. So the client sends a request, sends a standardized request to the MCP server. Now, your MCP server, once it receives the request, your MCP server is going to hit the GitHub API, retrieves the difference in the code, because a PR request means some kind of code change. And then it also runs the CI/CD test results. Like, for example, any new code, if it is supposed to be merged, it should undergo certain CI/CD tests. So it does all of that and then sends this back through the client to the agent as resources. So the client sends a standardized request to MCP server, and the MCP server accesses the GitHub API. GitHub API does the checks and sends back the response. Sends back the response as resources. So in order to send it back, in what direction would it send it back? The server has communication with the client. So through the client, this is being sent back to the agent or to the host. So the server, after it validates whatever is coming in, it is going to send back the resources that it has collated back to the host. So the server is going to say that I did the corresponding checks and this code seems all right. This code does not violate any of your test cases, and that information is sent back to the host. Now, the host sees that the CI/CD tests, everything has passed. Now, it determines that the code is safe and it meets all the required criteria. And then what should the host do? The host approves the PR, but how can it approve the PR? So in order to merge or in order to approve the PR, it needs to execute some kind of tool. So once this code approval is done, so I don't have much space here. So after the host understands that checks have passed, it triggers the, I'll just consider the tool as the merge tool. The merge tool along with the PR number. Along with the pull request number. And then your problem is sorted. Your merge is complete, and the host sends the command to the, so in order to perform the merging, now, in order to perform the merging, what should it do? The host will pass the command to the client, and the client sends the standard execution request to the server, and the server translates this into a GitHub API request, and that is where it finishes the merge. So now this is being passed to the, I'll use the same colors. This is being passed to the client, and via the client, the request is being sent to the server, and the server calls the accesses GitHub API, and it performs the merge. So in a nutshell, the server is what has access to the other end, which is your GitHub endpoint, and the host is your agent, and the client acts as an intermediary between the host and the server. So this is the complete flow of the host, the client, and the server, which are the major three components of your MCP protocol. So I know you might have any questions. Yeah. But in this whole flow, MCP host never knew about the repo code. So yeah, I'll be taking the questions now. So in this whole code, the MCP host never knew about the repository code. Only in sending 10-line changes, how will it review? MCP host is not reviewing it. Okay, the MCP host is not reviewing it. So the MCP host understands that there is a PR request that is raised. The trigger comes to the host. The code is not coming to the host. The host knows that, okay, there is a PR request that is raised. And then the host is going to ask the client to fetch the content or the information related to the PR. And then the client converts it to a standardized request format and sends it to the MCP server. The server is what has direct access to the GitHub repo. Okay. Now, the server accesses the GitHub API, and now the server has access to the code. Now, the server is going to perform the checks, and then the server is going to validate the CI/CD pipelines and all of that, because that is already a part of your GitHub. Now, the server understands that the new code passes all of the checks, passes all of the tests. Now, that information is transferred back via the client to the host. Now, the host receives information that the checks have been passed. The host did not do the checks. The host received information that the checks in the GitHub actions have been passed. Now, the host decides that, okay, this can be auto-merged. Now, that information that the merge can be done is passed to the client and then to the server. And the server performs the merge. All right. So how the system can decide which API requests it need to call, which API requests it need to call. Like in this get request need to be used, but how does the MCP server decides and then triggers the API? MCP server isn't deciding. The decision was made by the host. the decision is made by the host, which is transferred to the MCP server as a GET request via the MCP client. All right. Okay. So what if the logic of the code is not correct in the PR raised? So ideally the test cases should capture it, right? So the test cases should capture any change or any issue in the logic. So it could be the latency, it could be the logic. So this is just a superficial mention or superficial idea of how MCP components work with each other. So so Manoj, to answer your question, where does the MCP server, MCP host or the client or server will be available? Is it on GitHub itself or is it on the agent that we are supposed to create? So when we create an agent, so using Claude, when we create an agent, you will get a better understanding of what the MCP host is, what the client is, what the server is. So just to give you a high level idea, we are going to incorporate Claude with a couple of tools using MCP. So your Claude code, sorry, not Claude code, your Claude will be your MCP host. All right. And now the server and the client, we will talk about when we actually go to the implementation. Where is the LLM or API call in this flow? The LLM, if LLM and the decision making happens in the host. Is host sending API details to server or should you call this API? Host is sending the API details to server. What API details? API details of what? GitHub. So yeah, GitHub. So is host sending API details to server or should you call this API? So one moment. So the host is sending the API details to the server. Yes. Oh wait, why would the host send the API details to the server? The server is what is there at the GitHub end, right? The client just via the host, the client, via the client, the host communicates with the server that I need to check PR123. That trigger or that a decision is being passed to the MCP server via the client from the host. The MCP server will have the API which is provided by GitHub publicly. Can we create some custom ones also? You can create custom ones. We are actually doing it today. Oh, wait. Are you talking about custom APIs? So you can create your custom APIs. Yes, you can absolutely do that. So we are actually going to create a custom MCP which uses an API. In today's session, we will not be creating a custom API because creating custom API is going to be more work. You can absolutely do it, but to answer your question, right? One moment. Let me check the Q&A. It's been a while. Um, how will the host know that a pull request has been raised? Is it going to monitor regularly? No, it is like a webhook. That means a trigger. So it is like an event that is created. So can you draw a block diagram? Okay, explain the whole workflow, which will cover all the MCP host. Yeah, that is what I just covered, right? So you have the MCP host, you have the MCP client, and you have the MCP server. Yeah, one moment. If an AI agent using MCP can autonomously review and merge PRs on GitHub, how do we decide the boundary between automation and human judgment in code quality? This is exactly what we recently had a discussion in the organization about this. So if we decide to auto merge the PRs, how do we know which logic was better and which logic was inferior? So which is why it is better to have a human in the loop, at least for now. I think mostly in the what do you say, in the coming few months, that might also be eliminated. We'll have to see. But what I want to say is some things that you can focus on will be your test cases, will be your latency, will be your scaling aspects. So if you have proper test cases and if you have proper latency checks, I think that might suffice, right? Okay. Now, if there are multiple MCP servers, how is the flow decided to call which MCP server? So more than that, within one MCP server itself, you can have multiple tools as well. So there are complexities like that. I'm not going into that as of now. Action is done at the MCP server. Yes, you are right. Host and server are critiquing each other, not exactly. So host is at your application end, agentic application end, and the server is uh, at the GitHub end. So the communication is done between these via the client. Okay. Are there any rules or standards which tool can be used with the particular LLMs? Not really. Which tools can be used with particular LLMs? There are no restrictions with respect to that, because LLMs are just about the decision-making aspect. Can you please use MCP in weather example? We started it in the weather example. Okay, cool. So I'll take a look at it. Give me a moment. Let's first go to the implementation, and then we'll come back and we'll talk about this if you're fine with it, because we are quite out of time as of now. Can we not call the APIs and take the action on the pull request via the MCP client to MCP server and back the host? I understood. So you are talking about why can we not call execute APIs and take action on the pull request via MCP client to MCP server and back to the host? I'm trying to understand the question. Can we not call execute APIs and take the action on the pull request via the MCP client to MCP server and back to the host? Isn't that what we're doing here? Too much of information unable to absorb. All right, fine. Okay, let's not go into the details for now. Okay, let's keep it superficial. So we have the Claude here, and typically Claude can be used to answer any questions of yours, just like your ChatGPT. Okay, now our objective is to incorporate a couple of tools into Claude. And how do we do that will be the question today that we'll be addressing. All right. So we had a lot of topics and a lot of details to cover, which we are not. I understand, because a majority of the cohort will be confused if I go into the details for now. All right. So let's start with the demo part. Right? Do you need a break, or should we continue, Niyati? What do you think?
I think many people have been asking for the practical part, the demo part.
Yes, let's get
Maybe,
started with that.
yeah, because you've answered some questions in between, so some people did get a little bit of break, or if we'll run out of time, just want to cover everything.
Okay, fair, understood. So let's start with the demonstration. So in order to start with the demo, first thing, you have Claude installed. You also have the Node.js installed, right? Okay. Now, in order to start with it, here you can see that in my Claude here, when you click on the plus symbol here, and when you go to the connectors here, there are two connectors which are activated. And these two connectors were already activated by me, which is what you will be doing today. So the first thing that you will be using is something called superdata. So superdata here, this is superdata. And superdata is capable of performing video transcripts, or capable of performing web scraping, or capable of performing data extraction from different videos across the domains that you have. And we want Claude to perform to create a transcript, or we want Claude to perform an analysis on a YouTube video. So by default, it won't be able to process the YouTube video, and it won't be able to create an analysis of the video by going through the complete details of the video. And that is why we use the tool superdata for this purpose. So you might have other tools as well which can be used, just that we are using this particular tool here. And to get started with, I want you to go to superdata, and I want you to request request an API from superdata's end. So you have 100, everyone, even I, even you will have 100 free requests which you can use. And if you want, just Google superdata. Yeah, here, superdata.ai. Just go to this URL. Yeah. All right. You won't be able to see the connector because you are going to create it. Okay. You won't be able to see the connector. Don't worry about that. So this is superdata.ai. Go here and click on the get 100 free requests. And it is going to take you, it is going to ask a few questions. You can just click on other, and you can click on continue, and you will get an API key. So that API key is important for today's session. So get the API key, and then we can move ahead. So just click on other and click on continue, and next step, you will get the API key. And once you get the API key, we can go to the next step. Okay, got it. Perfect. Now, one moment here. So we will be using the Superdata MCP server in order to do this. And we will be incorporating that not with Claude Code, but with Claude Desktop. So in order to do this, what we are going to do is we require the Node.js here. And what we are going to do is, see, we have the Claude app, and your Claude app is going to be your MCP host. And your client is going to be the Claude model in the backend or the Claude's built-in MCP context in the backend. And the Claude model or the Claude's built-in MCP context will be your client that communicates that runs between your Claude application and the MCP server that you have. And this MCP server that you have is the Superdata MCP server. And how do you run this? In order to run this, first, let me share you this URL. So kindly follow the steps with me. I'm running this as a reduced. So my pace is quite slow as well. So I have pasted a link in the chat. Please click on the link and it will take you to this particular document. Now, I want you to copy this JSON. This JSON, I want you to copy it. Or before copying it, or copy it and then make a change to this. Insert your API key here. Okay. So I want you to insert the API key, your API key here, copy and paste it to your system and change this with your API key. And after that, copy this. Okay. Once this is copied, what I want you to do is, I want you to go to your system. And in your system, I want you to, if it is a Mac OS, I want you to go to this particular JSON file. If it is a Windows system, I want you to go to this particular JSON file. So after you go to that JSON file, in my Mac system, for instance, once I go to that JSON file is going to look like this. I mean, this is the modified JSON file that I have. So instead of that, I want you to paste this, whatever we copied, and then I want you to replace the API key here. Your own API key, please replace it here. And this will be your this will be your Claude desktop config.json. So once you have updated this, please let me know. Once you have updated it, please save it. The only change that you will require to make from the JSON I give you. Oh, hold on, please. 1 minute. This is for Mac, right? Let me just quickly check. Give me a moment. Windows users, please wait a moment. Because for Windows, I might have to make a change. Because I've never tested it on Windows, right? I've just tested it on my machine here. Okay. So for Windows, folks, this could be working. So let me just. I'm just pasting the Windows one here. Yeah. All right. So the Windows users and Mac users, you can copy paste your own appropriately, and then you can make change. You have to make change to the API key here, and you can make the change in the JSON. And if you do not have a code editor or something, it's absolutely fine. You can edit it in your, what do you say, your Notepad or whatever. And if you do not want to use Notepad at all, you can use your you can use your terminal as well. So what you can do is you can use terminal as well if you do not want to use your what do you say that if you do not want to use your um, code editors or something. So you can just go to terminal and you can go to that particular file path. So if you want the file path, that file path is here. Let me just copy that file path as well. Yeah, this is your file path. And for Windows, I'll just paste the file path here. Okay. So this is your file path for Windows as well. Okay. So go to that file path and replace it with this, but make a change for your API key here. Once you're done with that, please let me know. The file does not exist in your Mac. Create the file then. Oh, that's actually interesting. Are you sure the file does not exist in your path? Because when I had created this for the first time, this file was already existing, just that the content was different. We are changing. Okay, I'll tell you what we are doing by changing the config file. Give me a moment. Let me just. So this is the path. Can you please check your path? So Ishan, you were saying that okay, it exists. Good. Please replace it. Please replace the content of that file. The file is the cloud config.json, which is located in users, your username, library, application support, cloud. How to get the API key? I already mentioned how to get the API key, which has to go to one moment, which has to go to what was that link? The superdata.ai. So just go to superdata.ai here. Oh, wait. Yeah, this one. To get the API key, so I have given the link to this document to you. So please use this document. So I am adding the steps here to install Node.js, to download and install Cloud. Okay, all the steps are mentioned here. All right, I see new questions. Where should we copy this content? So I already mentioned if you're using a Mac OS, copy the replace this file, replace the content of this file with this content. And if you're using a Windows or operating system, replace this file with this one. Okay. I will repeat the entire process once again. The JSON file is non-editable. Sagar, do you why is it non-editable? Did you try using Nano? So if you want to edit the JSON file, just try using go to that particular folder and do nano space. Is it you are using it as Mac, right? Are you using Mac or are you using Windows, Sagar? Mac. So if you're using Mac, just do this, go to that particular folder and do nano space cloud desktop config.json. And once you do this, nano space that file, and that will open up, and then copy paste this one in that, and then press Control O and press enter. In Windows, it is not. Vijay, have you installed Claude in your system? If it is not available, create it, please. Yeah, exactly. Right click and opening it with the text editor will also work. And if it doesn't work, you can use sudo nano as well. For Windows, how to open the JSON file? Just go to this particular URL here in your system. And then if this exists, modify it. If it doesn't exist, create it. Yeah, if it has already some content in it, replace it completely. It's fine. So Dilshad, this session will be there for approximately at least 1 more hour because we want to complete the hands-on session as well. Yeah. Okay. So let me, yeah, can you share the Windows URL here? Okay, can do it. Unable to download Node.js. Did you go to the link? And what made you not, what was the error that you were facing? Your system is Windows, right? I'm not sure which is it. So if it is Windows, download error in Mac. What was the, see, I just ran this lines and it downloaded perfectly for me. What is the error that you're facing? Can you copy paste the error? Asking for Xcode, but Xcode is not required for this, right? I see the JSON path in Windows. Okay, thank you, Muthukrishnan, for providing the JSON path. Okay, thanks for that. I'll just update it. I was just following this um, or 1 moment. Yeah. JSON files are by default opened from Xcode. You can right click and open it in whichever editor that you want. Path cannot find in Windows. Can you try opening the alternate path that I have given here? Muthukrishnan shared it here in the chat. This is not opening. My app data does not have Claude. Can you try looking in local app data instead? Why is it, Muthukrishnan, by the way, why is your URL like this? I mean, Claude underscore some characters. Dinesh, it will take more time. Apologies for overshooting the time. Yeah. Can you share the document link? Yeah, I can share it again. Yeah. Not editable via nano in Mac. Can you try sudo nano? Neelam, can you try sudo space nano? All right. And Priyal, you asked, do you this JSON? Yeah, delete it and replace it with the JSON I gave. Yes. For apparently for in Windows, different people are having it in different folders. Library application, yeah. Claude is installed in Windows, but I don't see the file. Can you see this particular folder called Claude in your Windows C drive? So somewhere in app data Claude folder. Can you search and find it, please? Because if Claude is installed, that folder will be there in your system somewhere. Please ping the Mac path. It's in the document here. Here. Oh, here it is. I just pinged it here. All right. Okay, let's continue with this. So I'm going to continue with the demo. So yeah. So what we are doing is, okay. So what we are doing here is we are asking we are creating an MCP server and we are telling Claude that I'm creating or I am initializing an MCP server. And that MCP server will have the name superdata/MCP. And that is installed by using the Node.js, by using npx y is for ES command, and the superdata/MCP is being set up in the system. And your API key will be provided here. And once you do that, give me a moment, please. Yeah, once you do that, once you do that, please shut down Cloud Code and please reopen it. And then please check whether you are able to find something here as superdata/MCP under the plus symbol, under the connectors here. Are you able to find it? Just let me know with a yes or a no. No, you're not able to find it. So did you complete the steps? So did you close Claude and did you reopen it? This is not paid Claude, this is free. Yeah. On Mac, you are not able to find this path. Users, see, this is the path. Users/your username/library/application support/code/ this one. Yeah. Supervise, you're able to see. Perfect. In Windows, you are getting an error. So probably we'll take up the errors at the end if that's fine with you. All right. So here you have the connectors, and connector is enabled. So once that connector is enabled, the idea of super data is that, like you saw in the website, you can automatically transcribe or you can extract information from YouTube video. So what is that path? Which path? So Ashish, in the document, I've shared all of it. So I've shared the link to the document in the chat, right? So Swapnil, are you using a Mac or a Windows? After Nano, how can I close the file? After Nano, if you're using Windows, press Control O and then press Enter. If you're using Mac also, it's Control O, not Command O. Okay. You're not able to see the file in Windows. You will have to find it in your Windows machine. So exactly, Nachiketa, you will have to replace that file with the content that I shared with you. Give me a moment, please. Hi. Right. So yeah, you will have to replace that with the JSON file that I shared with you. Okay. So yeah, we'll go with the demo. At least in my system, we'll go with the demo. So yeah, you can just open a new tab in Claude and you can type your requirement, which is to transcribe the content of a YouTube video. You can choose whatever YouTube video that you want, and you can say transcribe the content of the YouTube video. And the moment you say this, it is going to load the tool and it is going to use the Superdata MCP. And it might ask, can I use this? Then you'll have to give a yes. And then it will provide you the full transcript of the video which you give. So it is able to do this. Your regular Claude will not be able to do this. But with Superdata MCP integration, it is able to do this. And what happened inside this is that we just provided a connection between our host, which is our Claude app, and the server, which is the Superdata, by using the client, which is the Claude model in the backend, to communicate with us. All right. And that connection you can disable anytime by disabling it here or enabling it here. All right. Please share the transcription text. I got the API key. Next, what needs to be done? It's in the same. It's in the document. You have to focus on the document. How can I do this with offline LLM model? With an offline LLM model, it depends on you will have to create. Then you will have to create an MCP for this, and you will have to incorporate that with the MCP. Then you will be able to do this. Okay. Apologies. So here is the document link once again. So let's go to the second part of the demo. In the second part of the demo, what we are going to do is we are going to, okay, I'll just showcase the second part of demo because we do not have enough time to wait for everybody to finish this. So kindly focus on finishing at least the first part of the demo. So in the second part of the demo, what we are going to do is, okay, we have this GitHub repository here. So that GitHub repository is mentioned here. So part 2 demo. So this GitHub repository is mentioned here. And in this GitHub repository, just go to the GitHub repository and download the files from it. And then add the files to a particular folder. The files in the GitHub repo will consist of your README is not important. The 3 files here, the 2ML file, the PY file, and the log file. You need to download all of 3 and you need to add them to a particular folder like this. Now that you have completed that, then after that, you need to, here. Now, you need to run the UV sync, UV space sync. So what you need to do is you need to open a terminal in this particular folder. So you can just, okay, you can just right click the folder and you can open a terminal in that folder. And this is how your terminal will look. And once you open the terminal inside that folder should already consist of the files that you have downloaded. After that, you can run UV space sync and it will install the prerequisites and it will create a virtual environment for you. And after installing the prerequisites and after creating the virtual environment, you need to run UV run MCP dev server.py. So it will trigger the server.py file here. And in the server.py file, I'll mention superficially as to what's happening here. So here we are creating. So we have an MCP by the name of weather, which we are creating. And this weather is what it is going to do is it is going to trigger the API from meteor.com. Meteor.com provides us the weather. And it makes asynchronous calls to get the weather request from this. Asynchronous calls means we won't be waiting for the response. It will be parallelly doing a lot of things. Out of that, one thing would be to create an asynchronous call to this. So this is you creating the what do you say? This is a boilerplate code to connect to the API that we are writing here, and we are going to get a response from the API here. Now, this MCP will be initialized. We'll be using it to initialize a tool, and this tool will be added to the server, to the MCP server that we have. And the MCP server is going to fetch us the correct weather by taking the latitude and longitude of the location. So the latitude and longitude of the location, we can either give it manually or we can make Claude identify the latitude and longitude of whatever location that we want. And that latitude and longitude will be used to trigger the get current weather. And the weather will be provided to you by the Meteor API. So that is what is going to happen here. So the Meteor API will be called here, and the latitude and longitude will be requested by the function, and it is going to provide you the weather. And that weather will be given, handed over back to the host, which is your Claude, and then the Claude provides the response based on the weather that it received. So here in the scenario, the host once again is the Claude app. The client is the Claude model that runs in the backend. And then the server is this one. The server is your weather API that you're triggering. All right. So the name of the server that we use is weather here, and we are adding a tool to the server, and that tool is to get this particular trigger this particular function. All right. Now here what we have is running the MCP server here, and we will be running the MCP server, and we'll be using the stdio to communicate between the API. Now, I just wanted to explain this code. So what you have to do is you have to do these two lines of code that I mentioned here in the folder, in a terminal inside the folder, and that folder should consist of this content that that is already shared with you in this particular what do you say, in this particular repo. So this particular repo, yeah, will be this. Now, once you finish that, once you finish these two, what I want you to do is for a Mac system, for Mac users, I want you to copy this. For Mac users, I want you to copy this entire JSON until this and replace the same file that you had earlier, which was this file, the Claude desktop config.json. And once you replace it, save it and close it, and close the Claude code as well, and open the Claude code once again. Okay. So one moment, you will have to replace this. This is my directory. You will have to replace it with your directory, which consists of the server.py. All right. And also for the Superdata API key, you will have to replace it with your own API key like you did earlier. Okay. So these are the two changes that you need to make for Mac users. And for Windows users, let me just figure it out what to do for Windows users. Give me Okay. So for Windows users, I'm just pasting it here. One moment. For Windows users, this should work. And you will have to change this folder, and you will have to change the API key. So once you do that, save it, close it, or close the Cloud Code as well, and open it once again. And now, when you open the Cloud Code, you will see that instead of one connector that you had earlier, you now have two connectors. One is the weather connector, and one is the super data MCP connector, which you already created. Now, if you want to see how the weather connector is triggered, just open it and then ask question like, what is the weather in Limerick, Ireland? And then it is going to trigger using the latitude and longitude. It is going to trigger that in order to find the weather, and then it is going to ask you the permission, and based on that, it is going to provide the weather back to you. I'm not sure whether this one used that. One moment. um, Latitude and longitude. One moment. Let me just check. Yeah, I'm not sure if the tool is triggered here. One moment. Connector is active. Okay, connectors are active, and okay. Anyway, this is the way to trigger a manual, or it is a way to create your own MCP server using an API that you are exposing. So if you want to create your own MCP server, first thing that you need to do is you need to expose your API of whatever tool that you're using. The API might be available. If the API is already available, you need to create a file like this, and then you need to create the connection, or you need to create the connector to the cloud. And then once that is done, the connectors will be available here. And then depending on the query that you will be asking, it is going to trigger the uh, particular tool. All right. So this is the demonstration, and I just wanted to show you the demo. Yeah, this is the YouTube video transcript request demo. Here it is. Not able to catch what you have shown in GitHub. I've shared the link to the GitHub repo in the document that I've already shared with you. Yeah, I've shown two different things. One is by using the super data MCP. Another is by using the weather MCP. So Neetu, to answer your question, this is the demonstration of the um, YouTube video translation request. Super data is not local one. Yes, you're right. Super data is not a local MCP. We are using an MCP server that super data provides us here. Please show the connector part again. So just click on this plus and check if you're able to view these two connections here. Looks like the version you are using and the one I got downloaded today have differences in the UI UX. I downloaded it today, by the way. I downloaded Claude today to this system. How the MCP got listed in Claude? The MCP got listed in Claude because you edited the Claude config. And in the Claude config, you explicitly said that you have multiple MCP servers. And that is why it got listed in Claude. You can create your own MCP, absolutely. So if you want to create your own MCP, the only thing is whatever tool that you're going to be using, you need to provide an API endpoint to it. And that API endpoint can be used in the same file to create your own MCP. So just that you change the names here, just change the API path and your own MCP is ready. All right. Okay. Can you please give the Git repo URL? Okay. The Git repo URL is already given in the document that I shared with you. All right, here it is. Where there is a local map server and super data is hosted where? Local map MCP server, you mean? Yeah, you said to replace a section, then you are able to get two MCPs. You said to replace a section, then you see when you do the second replacement here, okay, the second one, when you do it here, you can see that under the MCP servers, the first one is Superdata MCP. The second one is the weather. So that is why you have two of them there. So if you just follow the part one just gives you one of them, which is the Superdata. After doing part two, you will have two of them. All right. So here is the link. And here is the link in the chat. Yeah. And the link mentions the commands that you need to run. All right. There was an error reading or parsing the Claude desktop config JSON. That means when you copy pasted it, there was an error. So kindly copy paste it correctly. You have not closed the bracket. Your settings file is corrupted and has been reset to defaults. You need to reconfigure your preferences. This was working. So yeah, as a recap, let me just give a recap of that because I won't be able to address all of your queries because there are a lot of questions coming in the chat and we have a lot of participants. So first, you have to install Node.js. Then you have to download and install Claude. Then you have to get the API key from Superdata. After that, in macOS, you have to go to in macOS or the Windows OS, you have to go to the Claude desktop config JSON and you have to replace that JSON with this. Now, after that, if it is Windows, you can replace it like this. Now, after that, save the file, close it, and shut down your Claude code, reopen it again. And when you reopen it, you will be able to find one connector, which is the superdata/MCP. And then you will be able to ask it to transcribe your videos, YouTube videos. All right. And for part two, the second part, just go to this GitHub repo, download all the files from the GitHub repo, copy it to a folder. Inside the folder that you have downloaded the contents of the repo, open a terminal and execute these. And once you execute these two, for Mac users, you would be required to copy paste this configuration in the same config file. And for Windows users, you can copy paste this one instead. Just that you will have to make changes to your directory and the API key in both these scenarios. And once that is done, save it and close it. Close your Claude code. Close your Claude, open it again, and you will see two connectors for you this time. All right. So this is the workflow. This is how to do it. Yeah. Claude config does not exist in your system. You will have to find it. It is either so if you are able to find a folder in your C drive, which is called Claude. Okay. Then if Claude desktop config.json doesn't exist, you can create it. It should actually exist. A default one should be there. So Jagdish, are you making the edits in the same folder that you copied everything to? And if UV is not recognized, you can install it. One moment. UV is not recognized, you can use the bash or something to install it. Okay. One moment. One moment. This is going to be a simple fix. I'm unable to copy it from the chat. Yeah, this would solve it for you. So let me just share this with you. Using MCP connectors, we connect that. Yeah, correct. Please follow setting, develop, edit, config. Okay, thanks, Prabodh. Thanks for showing that. Okay. Mugda, can you show your directory of repo and the current? I cannot open that because it consists of my API key. So otherwise, it would have been fine to open that. But still, I think I'll open it. No worries. Yeah, where is my? These two are weather and YouTube are tools, right? The super data and weather are tools. You are right. Yeah. So this would be how it looks like after the first one. So I won't be able to show it because of the API key. That's all. So there was an error reading or passing the Claude desktop. One moment. So Swapnil, was it after the first part or was it after the second part? After the first part. Let me just check. Mac OS or Windows OS? Mac. It's correct. See, this one is closed here. This one is also closed. This one is also closed. This one is also closed. Can you please verify if it is correctly copied? Oh, how did you edit it, by the way? How did you make the edit? Did you use some TXT or did you use, okay, what I would recommend is use either the terminal or a code editor for this rather than using Notepad. Unable to replace, just open the JSON and paste this there directly. Sometimes Google Docs copy directly to Notepad gives issue. Yeah, thanks. Probably that's the issue. But can I add it as a code here in a different format? Format. No, does it have a provision to add code? No, right? Yeah, using VS Code or something like that. So Priel, the MCP inspector, what you're talking about is this. It's fine. Let it be there. All right. Okay. Still not seeing the connector in the cloud. Can you verify whether the config file is correctly updated? MCP weather server disconnected for troubleshooting guidance. Please visit our. Okay, I think I had faced that error. So for Mac users, for Windows users, if it throws an error, use this one. So try to check which UV in your system, identify the path to the UV, copy paste that path, and replace it instead of the UV here. Replace that with the path. Okay, and then it will work. For second demo, just download all the files from the GitHub repo, copy to a folder, open a terminal in that folder, and then perform these two. And after that, just replace the file, and then you'll be good to go. You're stuck in the first part itself. Where do I see the connector? Just go to Claude, click on the plus, go to connectors, and you will be able to see the connectors here. You can disconnect them whenever you require. So, okay, Srikanth, you're talking about you're stuck. So you are not able to find, you found the folder of Claude. Then if you found the folder of Claude, do you have that file inside that? Okay. If you have the file inside that, did you replace the file with the path that I gave? Okay. After that, did you shut down Claude? Did you save that file? And did you reopen Claude? Okay. Were you able to see the connector? Okay. Can you, without closing Claude, can you go back and can you open that config file once again? Can you check whether the file is still the updated file or did it get replaced? Everybody has access to this, right? I mean, you don't commenter, okay. But editor, no. You can comment it if you would like. Yeah. How do you get the super data API key? It's mentioned in the document. Just go to this link and you can get the API key by clicking on. Just go to this link and just click on the 100 free requests and you can get the API key here. All right. Okay. Your file is getting defaulted to original data. Are you facing this issue in Windows or are you facing this issue in Mac? Mac. Okay. Can you do something? Can you do a sudo change? Can you do sudo nano followed by that file name and then make the change? You're not able to delete. So Windows. Okay. Most of you are facing the issue in Windows. I haven't tried it in Windows. Probably I'll try it and then I'll let you know. Okay. So you will have to, yeah, you will have to completely shut down the Claude process. So once again, open your what do you say, window in Windows, what is that thing called, Task Manager, or in Mac, you can go to the activity monitor and you will have to close all of it and then you will have to open it. Okay. Yeah. Oh, Swapnil, thanks for that. You in Mac, the folder was hidden. Okay. So if UV is not found, you can install UV. By the way, if UV is not found, just a quick question. Are you using it in the same folder as that of the folder that, are you opening the terminal in the same folder as that of the folder that you pasted all of these files that you downloaded? And still, if UV is not found, you can install UV into your system. You can just ask ChatGPT on how to install UV and it is going to sorted. All right, folks, I think we can wrap it up. Sorry about this. So we need to wrap it up. If you're still facing issues for tomorrow, I have a session tomorrow. We can solve the questions. Okay. Once open in Nano, just press Control O and you will be Control O followed by Enter and you will be saving. Okay. All right. Thank you. Thanks, folks. I have a hard stop now. Yeah. Thank you. Yeah. Sorry about going overboard with respect to time. All right.
No, thanks a lot, Justin. I think we were able to cover most of it, and people have understood how to connect it to Claude, and I think you answered almost everything possible. So that's great on your part. Thanks for taking out the time. Everybody, I'm launching the last poll of the day, where we obviously want to host you again tomorrow because we are going to do a lot of things tomorrow also. So go ahead, just fill in a little bit of feedback, and if you're going to join us tomorrow, let us know. It'll be great if you do, because Justin is going to take another session, and maybe some of the questions if you had from today's session, you can ask tomorrow. We'll be happy to take that. Yeah, so just going to keep the poll live for some time, and then we can all drop off and see you guys tomorrow then. Some of you are asking what's the agenda for tomorrow. So we are going to get into multi-agent orchestration tomorrow, and also take the agent to production. We are going to give you slides in a few days and through the Discord and Slack communities. Tomorrow session is also the same time. Join us at 12 p.m. and we'll be concluding around a little before today, because today was mainly the setup. So yeah. Okay, thank you so much, guys. I have kept the poll open for the last 15 seconds. Go ahead, answer that. And yeah, cool. Thank you. Thank you so much, guys. Have a good evening, rest of the Saturday, and see you tomorrow at 12 p.m.